Okay, on to our first lesson. The first thing that we're going to cover is going to be strings. And in order to do that, I'm going to go ahead and make a directory on my Linux machine. You can make a folder in your Mac or your Windows machine if you're using those operating systems. I'm just going to go in here and just say make dir python, and then I'm going to go ahead and go into that directory. So from here, I'm going to go ahead and make my first script. So I'm going to clear my screen with Control L, and I'm going to say mousepad, and I'm just going to call this script first.py. And I'm going to give it the ampersand here at the end. That's just going to allow me to open up this process of mousepad and also have the terminal available to me when I need it. So you'll see why I do that here in a little bit. Now, if you're not on Linux, that's okay. You can use something like Notepad++ or CodeRunner for Mac, which we showed earlier in this course. So from here, what I'm going to do is I'm going to go ahead and enter in a shebang, which is a hash and an exclamation /bin /python3. And this is important for Linux here because we are calling out the directory. If you're familiar with Linux, what's happening here is we have two options. We can come in here and we can say python3 and we can say first.py and that'll execute our script. Or in theory, we can come in here, we can just do a ./first.py and run it that way. If we run it like this, our script will not know where to go unless we declare that. So up here, we're giving the shebang /bin /python3. That is where python3 is located in this machine. So it will come up here and it will look for this first and say, okay, I'm going to execute this based on python3. So that is a little bit of a Linux nuance here and something you should know in case you are ever coding in Linux or an environment that is similar like Unix, which Macs do run off of. So from here, if you've ever taken a coding class, the first thing you do in every single coding class is what is known as hello world. So we're going to print out hello world and print it to our terminal. So in order to do that, we're going to go ahead and do something like this. We're going to say print, and then we'll do a parentheses and we'll say hello world. I'm going to go ahead and save this. And if we run this, and I'm going to run this with python3, if we run this, python3 first.py, you'll see that it says hello world. Now, one thing that we can do in here is good practice for being a developer is add some notes in. So we're going to add a comment in here. We're going to do a hashtag or a pound symbol, and we're just going to say print string. Now, when we run this again, this isn't going to print out. Comments are just for us inside of the script, and I can prove that to you by saving this and running it again. You'll see all we have in here is hello world. Perfect. So comments with a hash are just meant for whoever is reading your script or your code. And that could be you, or bad scenario, but what if you get hit by a bus tomorrow? You're the main developer and nobody knows how to read your code because you didn't leave any comments. That'd be very bad. So good coding practice suggests to leave good comments and make sure that people can come in and read your code and understand what is going on in here. So we're going to add comments along the way so that way we understand what we're doing and practice good habits as well. So what you're seeing here is what's called a string. You're seeing a string in quotations. And you can see a string printed out with single quotes as well. So we can just do hello world. I'll add the exclamation for consistency. And if we save this and print this, you'll see that it also prints hello world. So it really doesn't matter if you have single quotes or double quotes until we get into more advanced strings, and we'll talk about those a little bit later on in the course. But for now, just know that you can use single quotes or double quotes when printing out a string. Another thing that we can do with strings is print on multiple lines. So if we say print and we do triple quotes like this, we say this string runs, and then we hit enter, multiple lines with an exclamation and add in 3 more double quotes there. and close this off, we can add a note here as well that says triple quote for multi-line. And if we save this with Control S and we run this again, you're going to see this string runs multiple lines. Awesome. Another thing that we can do is concatenate strings. So we can print out something like this string is, and now we're going to add a space at the end of it. Make sure you have a space right here. We're going to do a plus sign, and then we're going to say awesome. Just like that. And we can say we can also concatenate. It's always hard for me to spell that. So what's going to happen here is it's going to take this string plus this string when it prints out. So the reason we have a space is it's got to have the space because there's no space here, and this won't just add a space for us, even though in our heads we might want it to. So we're going to go ahead and save this, print it out one more time, and you can see that it concatenated and said this string is awesome. Now, one last thing. We can also print out a new line. So we can just do something like this. And we can use a single quote this time just to do a proof of concept. Do a \n like this. And this will print out a new line. And we'll get familiar with that later on. As we get into functions, we'll write our own function to make a new line. But for now, if we wanted to add another line, we could, and then we can just print test that new line out. And let's see if it actually gave us a line printed in between this concatenation and this new print statement here. Let's go ahead and save that. We'll print it. And you can see there is a line here. So the \n will print out a new line for us. And that is all we need to know for basic strings. So we're going to go ahead and move on to math. You can go ahead and leave this open. We're going to run through this as we go, and then you'll have a long script, which will also make for very good notes. Let's go ahead and move on to math. So math. Python actually has a built-in math interpreter. So we can do a bunch of fun stuff with Python and with math that's automatically built in. So I'm going to go ahead and just call this section math. And if you want to keep track of sections, you can come up here and just call this strings and just capitalize it like that. And then that way we kind of have an idea of where we're at. You can even add an extra line here if we want to. So from here, let's go ahead and play around with math just a little bit. So if I wanted to do a print of 50 plus 50, we can definitely add. We can also subtract. So if you want to do 50 minus 50, you could do that. And I'll give you some time to catch up here in just a second. I'm just going to do a few print statements, then we'll take a look at them, and then we'll move on to some more math as well. We can also do 50 times 50. And we'll just use the little star or the asterisk. We'll just say multiply. And we'll also do 50 divided by 50. We'll just say divide. So if we save that, you could take a second to catch up. You could see we are just doing simple math here. We should expect 100. We should expect 0. We should expect 1 here and 2,500 if my mental math is correct. So I'm going to go ahead and print this out. Okay, and we've got 100, 0, 2,500, and 1.0. So this 1.0 is a little bit different. This is what's known as a float. Everything else that has come out so far is just an integer. And we'll talk a little bit about that here in just a few minutes, but know that integers are on the left-hand side. And if we don't have a decimal point here, we're looking at integers. And on the right-hand side, when we see anything on the right-hand side of the decimal, we're looking at what is called a float. And that becomes very important depending on when we need it. For now, we're going to keep worrying about math. We'll get into integers and floats in just a little bit. So another thing that math built into Python can do is it can do PEMDAS. If you've never heard of PEMDAS, please excuse my dear Aunt Sally. So parentheses, exponents, multiply, divide, add, subtract. You may have had it something different within your educational experience, but it will do that for you. So if you do 50 plus 50 minus 50 times 50 divided by 50, it will give you the answer. I don't know that mental math offhand. Another thing that we can do are exponents. So we can print, say, 50 to the second power, which is the same thing as 50 times 50, which would be 2,500 as well. And we can get exponents out of this. And we'll actually go ahead and save this and run this here because the next stuff I want to be able to lay out clearly. So you can see that we have successfully done the math here. It did it for us. Awesome. And it also did the exponent for us as well. So now a couple of weird things with division. So you saw the 1.0 before. Well, we have a few things that we can do. For example, the 50 divided by 6, but using a percentage sign is what's called a modulo. And that, it just takes what is left over. So 50 divided by 6 is not divisible. There is a leftover. So if we print that, you'll see we get a leftover of 2, which makes sense because 6 goes into 50 8 times. 6 times 8 is 48. And then we have 2 left over. So if we want to know what the remainder is, we can use a percentage sign here. We can also do something like 50 divided by 6, like we saw earlier. And this will have division with remainder. So we can say or float. We'll save that and take a look at that really quick. You can see we get 8.3, and then it rounds up eventually to a 4. And lastly, what if we wanted no remainder? So if we just did 50 divided by 6, we say no remainder. We could do this, and we should get 8 here. So depending on the situation and what we want, we might want a situation where we only want the integer, or we only might want what's left over, or perhaps we actually want the full number of what's being divided. So there are a few different ways to divide with math in Python, and it's good to know all of them depending on the situation that you run into. So for now, just take notes on this and know that there are a few ways to do math and division, and you can do PEMDAS and exponents and all kinds of fun stuff, and this is just scratching the surface of math with Python. So that's it for this lesson. We're going to go ahead and move on to the next one, which is going to start covering variables and methods. So I'm going to come in here and I'm just going to call this section variables and methods. And if we want to make our script a little bit clean, we can just come in here and copy this new line. It'll be a lot easier once we write a function for this, but we haven't gotten there quite yet. So we're going to print out this new line, and that way when we print this out, you could see that we have kind of gaps in between the sections that we're working on. So now we're going to work on variables and methods. So variables. Variable means something can vary. It can change, and we're going to look at that here in a second. So if we have something like quote, and we make quote equal to all is fair in love and war. And this is what? This is a string. We are storing this string inside of this variable called quote. And we can just come in here now and we can print out quote. And if we do that, we should get this returned back to us. You can see all is fair in love and war. If we didn't print this, just go ahead. Actually, we'll just comment this out. This is a great way to test the script. If we just save this now with a comment and we hit enter, there's nothing here. We haven't given it any instructions to actually print out. So now we can print this out, and it's printing whatever is stored inside of that variable. In this instance, we have a string stored in there. Now, when we talk about methods, methods are just functions that are available for a given object. Now you could think of functions as something built into Python that allows us to do something. And it'll make sense here when we get into using methods. So we have this quote, "All is fair in love and war." Well, what if we wanted to print this in a few different ways? Well, we can use methods to do that. For example, we can print quote in uppercase and just do upper like that. And this is going to make it all uppercase because we're giving it this period, upper, and then open close parentheses right here. And that is allowing us to use that method. So we can say uppercase. And we can also print in lowercase. If we do lower. And just for one more, we can also do print, and we'll say quote.title. And this is what's known as title case. And title case will capitalize every single letter like it is the title. In this instance here, we're going to get like the A capitalized, which wouldn't really be true in a title, but still just know that title case is meant to capitalize every first letter within your string or your sentence in this case. We're going to call this lowercase here. Okay, so let's go ahead and save this, and we're going to print this out. And you can see the differences that we have. We have it here in its normal quote, and then we have it in uppercase, all lowercase, and then every single first letter capitalized. Perfect. These are methods. These are just a small example of methods. We're going to get into more a little bit later. Here's another example. What if we wanted to print the length of quote? Let's say we wanted to know how many characters were within this sentence. So this is going to count the characters. And this will also count spaces. So we're trying to get a total count of what's going on inside this string. We print that. You'll see that we get 28 return. So if you want to check that, you can go count every single character within here, and you'll get the length of that. And that could become important as you're doing Python later on. And this is just yet another example of a method. Now let's go back to looking at variables and why they're called variables. So let's say that we have a variable of a name. And in this instance, I'm going to use my name, and I'm going to make it a string. And I'm going to use my age. I am 33. And here we're going to say string just so we can make sure we notate the differences. This is an int or an integer. And we're also going to give a GPA. Let's say I went to school, and I'm going to use the American grading system. Let's say I had a 3.7 GPA, and this is what's known as a float. And that has a decimal, so make sure you notate that. So if we print these out, if we print out the integer of age, that'll still print 33. What if we print out the integer of 30.1? Save that. Take a look. And you'll see that we just get 30. All right. And you can see that this rounded down. Again, integer, just the first number, just what's on the left side of the decimal point. Doesn't care about the right side. What if we printed integer of 30.9? Will it round? Will it round? No. So if we save that and we print again, you'll see it's still 30. It doesn't care what's on the right side of the number. It's only going to take what the integer is. So anytime you print an integer, you're only going to get the first, or what's on the left-hand side of the decimal point. So make sure you know that. Now, a few cool things that we can do. Let's say that we wanted to print something like this. If we print my name is with a space, and then we'll do plus name, and we'll say space again, and I am space age plus space years old. Make sure you have your spacing in there properly. That way you can account for the spaces before and after these variables. But what are we doing here? We are concatenating variables. Now, if I try to run this, I'm actually going to get an error. If I run it, we're getting a type error. And this is a great example, by the way, of understanding what Python is telling you. I get emails all the time from students saying, I don't understand why my script isn't working. And the first thing I'll ask them is I will say, did you read the output of the error? Because it tells you, it says, hey, on line 44, if I Control Tab, look, this is line 44. It tells you where your mistake is. And then it also says, can only concatenate string, not int to string. So if you didn't know what this meant, and maybe you don't, you can copy this, go to Google and search it, and I promise you somebody will have had this error before. As much as we wish to be special, there's not many situations that will come up where there hasn't been this error or an issue that we run into that somebody hasn't already had before. So with that in mind, we can fix this. So it's saying that it can only concatenate strings, not integers. Well, name is a string, but age is an integer. So we need to make, in this situation, age a string. So what we're going to do is just say str, like this, and give it like that. And now if we print this, save it, print it, you can see my name is Heath and I am 33 years old. Perfect. Now, what happens if I am a year older? Well, I could take age and do something like plus equals 1, something like that. And if I print age now, hopefully, we are seeing 34. You can see 34. Now, this is what comes into play. This is a variable. Variables can change. At this point in the script, we define that we are 33. And as we run through it, I am still 33 when I print this statement out. However, I've had a birthday now. Age has increased by 1. Printing age out now will say that I'm 34. So variables can change. Variables can store different numbers at different times. That's why they are called variables, because they vary. Now, we could also do something like birthday and set birthday equal to 1. And I could say age plus equals birthday and then print age. And guess what? Now it's going to return 35. So just know that you can store a number within a variable. We've shown that before already. We can add two integers together and we can print them out. So we're adding those together and it's taking that total and adding that to age. And now it's saying we're 35 years old. So that is it for this lesson. We're going to go ahead and move on to functions and fix this new line issue that we've had, plus write some pretty cool stuff out and build some other cool functions out as well. So I'll go ahead and see you over in the next lesson. All right, moving on to functions. So let's go ahead and print out a new line really quick. And we're going to call this functions. Now, I like to think of functions as mini programs. What they are is an organized block of code that you define, and then you can call it later instead of repeatedly typing the code out. So we're going to take a look at some examples of that. So let's go ahead and write a function. So let's do a define, def, and that's how we start a function. And in this one, I'm going to say, who am I? And I'm going to do close parentheses. And here we're going to say, this is a function without parameters. And we'll talk about that here in just a little bit. Now, indentation is incredibly important in Python. If we do not indent, we will throw an error here. And you're going to see a lot of situations where indentation becomes incredibly important. It's one of the most important things in Python. Python does not have a lot of rules that apply to it, but indentation is one of them that you must follow. So we're going to go ahead and hit the tab to indent. and I'm going to say my name is Heath. And this is what is known as a local variable. We'll talk about that here in a second as well. Age is equal to 30. And we're going to go ahead and print. Same thing we did before. We can actually just kind of copy this up here. We'll say my name is just like this. Okay. Copy all that, paste it, and then add the close parentheses there. I'll let you catch up. And then we can just call down here, who am I? So what's going on in here? Well, we have a function that we're defining. We're calling it who am I? And it has no parameters. We'll get into parameters here in just a second. Now we're giving it some items within this. In this instance, what we're doing is we're giving this local variables. We're saying, hey, in this instance, when we have a variable of name, it's going to be Heath, and the age is going to be 30. Well, whatever is stored in here is only stored within the function. That's why this is a local variable. If we print age as well, we'll see that. So we know that age was 35. We called age over here as 30, and let's see what happens. First of all, we called our function here. We said, who am I? Called that. And all it does is run our mini program. Our mini program says, hey, I'm going to print out these variables into this string here. Okay? And that's exactly what it did. But when we printed age again, you could see that we're actually still 35. So this variable, or the variables that are within a function, are local and do not apply outside of the function. So make sure to remember that. Okay, so I'm going to delete this print statement. We don't need it. And we're going to write some more functions. So let's do one where we add some parameters. So we're going to do add 100. And we're going to give this a parameter of num, N-U-M. And that's just going to stand for number. Okay, we're going to indent, make sure we indent. And all we're going to do is print num plus 100. So when we call our function, we say add 100, just like last time. This time we have to actually give it what is called an argument. So our argument goes with our parameter here when we're calling it. So our argument is going to be 100. And when we print this out, this is going to be 200, hopefully. So we'll save this, run it. And you can see that we got 200 because we're doing print 100 plus 100. That's all we're doing is this mini program. Okay, let's try another one. Let's say we want to have multiple parameters. Let's do define add, and we're just going to add x and y. This one's going to be easy. We're just going to say print x plus y. And now we can add whatever we want. So let's add 7 and 7. And one will take the place of x. The other one will take the place of y. X plus y, 7 plus 7 should be 14. So let's go ahead and run that. You'll see we get 14 here. Beautiful. All right, let's make it a little bit more complicated then. All right, let's try adding in here another function. This time we're going to do multiply. We're going to do x and y again. And instead of doing a print, I want to show you something a little bit different. Let's say we just return x times y. And now in this instance, if we multiply 7 times 7, do we get 49? We don't. Okay, there's a reason for this. This is just calling back. So when this is saying return, this isn't saying print. Remember, this says print. This is going to return x times y. So we can call this here, this function, and it knows that this function is equal to 49, and perhaps we can put that into something else. Like we could put that maybe into a variable or whatever it is we might want to do with it. However, if we wanted to return it to the screen, we actually have to call that. So sometimes we're going to actually store something instead of printing it. We do a lot of printing in Python tutorials just so that you can see it on the screen and make sure that you're seeing what you're doing and that everything's printing out okay. So that's why we're doing this, but please understand that the return option does exist and is used quite frequently. So I'm going to save this and run this. And you can see now that we get 49. Perfect. Okay, 2 more. Let's say we want to do a square root. Okay, so let's define square root. And we're just going to give it 1 parameter. And in this instance, we're going to print out the square root. So we're going to take x, and a square root in exponent format is just to the power of 0.5. That's all we're doing. And we can test that theory by doing something like square root of 64, which we should return as 8, because 8 times 8 is 64. So if we save that, come in here, print it, and you can see we get a float of 8.0. Now, I told you we would create our own function for a new line, and we're going to do just that. Let's go ahead and define new line. And we could call this like new line if we wanted to or whatever, but I think to make it simple, as long as we understand what it is, we can make comments and notes in here if we wanted to. We could just say define NL, and then we can just say that when we do that, we're just going to print out our N for our new line. And then we call a new line, we'll get one. Very simple. So we can just even say in here, new line. Okay, so now we know. And we save that and we can print it. You'll see it. It's here, but we really don't have anything after it to really show it, but we do have that space there. So that is it for this lesson. I'll go ahead and see you over in the next one. Next up, we're going to learn about Boolean expressions and also relational and Boolean operators. So let's go ahead and type in here Boolean expressions. And when we think of these, we can just think of this as true or false. That's really what it is. So from here, let's do a few variables. So we could set bool1 equal to true. We're just going to say, hey, this variable's true. Bool2, we could set equal to 3 times 3 is equal to 9. So the double equals means that something is equal to something. So we have 3 times 3, that's 9, equal, that means that equals 9. Do not confuse that with setting up your variable. This is saying, hey, my variable is equal to this, but this is saying this is equal to this number. Okay, and that is a true statement. We could also say bool3 and make that false, or we can give it a statement that makes it false. So something like 3 times 3 does not equal 9. Exclamation equals means does not equal 9. Now, if we print it out, bool1, bool2, bool3, and bool4, just like that, and save it, and if we come in here, you'll see that it says true, true, false, false. Again, Boolean expressions. Is something true? Is something false? Why do we need to know this? Well, we need to know if something is true, then we might want to continue on. Or if something is false, we might want to do something. And we'll get into that when we get into conditional statements. Like, if something is true, then go ahead and do this. If something is false, do this. Or there's something called while loops, which will allow us to continue as long as something is true. We're going to get there when we get to conditional statements as well, or looping, I should say, and we'll talk about that. But that is why we might want to know these things. Among other stuff, we might want to know if something's true, or set that parameter or that variable to true until it becomes false. etc., etc. So right now, just understand that Boolean expressions are true or false. And we're going to come in here and we're going to print, and we're going to say type, and we're going to do bool1. Okay, and this will tell us. Now, this is the nice thing. So if we come in here and say type, it'll give us the class. This class is Boolean. Awesome. And another example of that is if we say like bool5 is equal to true, and we print the type. So if you see true and you're like, I wonder what that is that Boolean or is it actually just a string? We can come in here and say bool5. We save that there, and then you should see that that class is actually a string here. So you can check with the type to see what is this. Okay, so the type feature is very nice, and we can see that we are dealing with a Boolean here, and this one is actually a string. So please note that if you put it in quotations, that makes it a string. If you leave it like this, that makes it a Boolean expression. Let's go ahead and make a new line, and we're going to talk about relational and Boolean operators. Okay. So we can think of that as, let's make a variable here. We say greater than, we say 7 is greater than 5. Well, that would be true. And we are using an operator here. So the operator is the greater than sign. We're also using a Boolean expression because it's going to result in a true returned if we were to print that out. Now, we can do a few other things. We can say like, less than is equal to 5 is less than 7. We can do greater than or equal to, which would be 7 is greater than or equal to 7. That's true. We can also do less than or equal to. And in that case, we can do 7 is less than or equal to 7, which is also true. So all of these statements here are true. Now we can get into some other type of operators and statements here. What if we did and? So let's just call this test, and we're going to do test and. We say 7 is greater than 5. Well, that's true. And 5 is less than 7. That's also true. Both statements are true, thus this is true. Do another one. Test and 2. And for some students, this does take a little bit to get your head wrapped around. I'm going to provide a table for you here just in a second, but just follow along and I'll explain this as we go. Let's say we have 7 is greater than 5 and 5 is greater than 7. Sorry, let me fix that syntax. 5 is greater than 7. This now becomes false. Why? Well, 7 is greater than 5, and 5 is greater than 7. That's not true. So, because it's not true, because both statements are not true, this becomes false. There's an alternative to this. What if we had an or? We said or. So 7 is greater than 5, or 5 is less than 7. Well, both statements are true. Thus, this is true. But we can have the same situation as before, where we have 7 is greater than 5, or 5 is greater than 7. And guess what? This statement is actually true. Because all we need is one condition to be true for this to be true. So in this situation, this is true, or if this is true, then the whole thing becomes true. So just because this is false, this would also have to be false for this to be false. Hopefully that makes sense. One other thing here, before I show you the cool little table, is we could do test not. So if we said something was not true, guess what? That becomes false. Same thing, if we said it was not false, then it's true. Not is just the opposite. So not true in this situation is false. Now, if we go out to the internet and we go to Google, we could come in here and we can just search something like Python truth table. And if we go to images, we should be able to find one that works out pretty well in our favor. Here's a good example right here. So if you ever take a coding class, you might be quizzed on this. This will tell you truth tables right here. So if it's not false, it's true. If it's not true, it's false. We can look at or statements. So true or false is true. The only situation an or statement becomes false is when both are false. Now the and, we looked at that. If it's true and false, it's false. If it's false and true or false and false, it's still false. Only situation for and where it can be true is when both are true. There's also not or, not and. There is does not equal or equals. So it's good to know these types of truth tables, and you can come and just, again, Google Python truth table and come look up this. Pretty straightforward once you get the hang of it, but it's completely okay for right now for it to be confusing. Just wanted you to know that these are out there and exist in case you are a little bit confused by this lesson. So we're going to go ahead and move on to the next lesson, which is going to cover conditional statements. Okay, we'll come in here, we'll do a new line, and we'll just say conditional statements. And we can think of this as if, then, or if, then, else, or if, else. Either way you want to write this is fine. So think about this. If you go to the store and you want to buy a drink, and that drink is $2. If you have $2 or more, you can buy the drink. If you do not have $2, you will not be able to buy the drink. So let's take a look at that. So if we write a function and we call it define drink, and we give it a parameter of money, we come in here and we say if money is greater than or equal to 2, then we're going to return. Look at the indentation again. We need an indent here after our function, and we need an indent after our if statement. So make sure you're indenting correctly. Return, you've got yourself a drink. And here, we come back, we can say else. We're going to return no drink for you. Kind of like Seinfeld, no soup for you. All right, so if we come in here and we print drink of 3, meaning we had $3 at the time, and we print drink of 1, meaning we had $1 at the time, we're going to have 2 different results. If we have 2 or more dollars, we're going to return you've got yourself a drink. Otherwise, if we have less than $2, we're going to say no drink for you. So let's save that. You've got yourself a drink when we print out $3 because we had enough money. Here you can see with $1 we did not have enough money, thus no drink for us. Okay, let's take a look at a little bit more of a complicated one. We're going to come in here, we're going to say define. Now, I'm going to make this alcoholic beverages. If you do not drink, that's okay. You can just follow along still. You can change it into whatever you want to be. But I think this is a good example because we have a couple parameters and we can use those to make different sort of conditional statements. So let's define alcohol. Now, in the United States, we have 2 things that we need in order to purchase alcohol. 1, we have to be old enough. We also have to have enough money, similar to the drink before that was non-alcoholic, we assume. Well, we have to actually be old enough to purchase this drink. In the United States, you have to be 21. So, if our age is greater than or equal to 21, let me put a space here, by the way, sorry. And, look, the and is coming into play. Money is greater than or equal to 5. Then we're going to return, we're getting a drink. All right. Now we're going to say else if, because there's a few situations that we can be in. There's actually 4 situations here. So we're going to say ELIF, which stands for else if. What happens if our age is greater than or equal to 21 and we don't have enough money? So we say money is less than 5. Well, in that situation, we're going to return, come back with more money. Okay, and then what if we have another situation where we say age is less than 21 and we actually have money? We're just an underage person trying to buy a drink and we say $5. Well, we're going to return, nice try, kid. And then lastly, if we have no monies and we're not old enough, well then we can just return something like you're too young and too poor. Okay, and then let's try these out. So we've got these different situations here again. Okay, if we have our age and money, we meet both criteria, we're getting a drink. Otherwise, if we meet the age but no money, let's come back with more money. We don't meet the age but we have the money, nice try, kid. And then lastly, if you don't have the money and you're not old enough, you're going to be too young and too poor. So we're going to print out a few different statements here of this function. So let's give it 21 and 5. We'll print alcohol again of 21 and 4. Print alcohol of 20 and 5. And these should all meet different criteria, alcohol of 20 and 4. So we should expect to get these in order. We meet what we need here. We don't. Different criteria for each of these. We'll save this. Go ahead and run this. And you can see it says, no drink for you. Actually, that's the last one. We're getting a drink. Come back with more money. Nice try, kid. And you're too young and too poor. So you can see that we can make conditional statements based on everything that we're starting to put together here. We have now used a function. We've used multiple parameters. We've used a conditional statement. We've used relational operators. Okay, we've got the Boolean, right? This is true and true. We're returning something. This is true and true in this situation. Then we're going to return something else. So we have different situations that can come back. So we need to meet those criteria, and we're starting to use that. Look, we're reusing the return instead of the print feature. There's a bunch of different things that we're doing here that's all starting to tie in. And hopefully that's starting to make sense why we do things. We're starting to build upon it, and it's starting to get a little bit more fun. So from here, we're going to go ahead and move on to lists and move on with our journey into Python. So I'll see you in the next lesson. Let's move on to lists. So let's go ahead and do our new line, and we'll call it lists. And the best way to think of lists, in my opinion, is that they have brackets, something like this. Now, lists are data structures. They are changeable. We can reorder them. They are basically just a group of elements. Now, everything within a list is called an item. And as I mentioned, the best way to think about lists is that they have brackets. Just like a string might have quotes around it, lists will have brackets around it. Now, again, we need to remember these are changeable. We'll talk about something here in a little bit that is not changeable, which is called a tuple. Now here, let's go ahead and declare a list. We're going to say movies. And I'm just going to list out some movies that I like. And we can do a bracket, and I can say when Harry met Sally. We'll just give these as strings. I like The Hangover. And I like The Perks of Being a Wallflower. Now you can add whatever you like here. And my hangover here, by the way, I have the hangover here. My hangover on the line here is just because my notepad here is not wide enough. If I made it wider, it would actually just continue on. So don't confuse this. If I hit enter, you'll see it goes to 148. So my wrapping does not mean I went into a new line. And lastly, we'll just say The Exorcist. Okay, and we'll close the list off with a close bracket. So if I wanted to print the first movie in the list. If I wanted to print When Harry Met Sally, I come in here and I print movies and I wanted to say 1. Do we think that would print the first item in the list? Go ahead and hit save, print, and you're going to see that it actually prints The Hangover. So what am I doing here? I am calling an index, and our index actually starts with the number 0. So when we look at an index, we need to think of it as 0, 1, 2, 3. Always count starting with 0, not 1. Otherwise, you can return the wrong numbers, and this can get very confusing. Let's make sure we add a note to this. Returns the second item in the list. Okay, we're looking at the second item with the index of 1. If we printed, for example, movies, and we gave it 0, then we would see that this will return the first item in the list. Okay, we'll save that, take a look real quick. You could see that the first item is When Harry Met Sally, and that's exactly what we're getting returned, which is what we want. Now let's look at a few tricks to splicing an index or indices. We can say something like print movies. And if we printed movies 1 to 3, what would happen here? Well, what's going to happen is it's going to return the first item given. So this is going to be index number 1, which is item 2. So first, I should say first index number given right until the last number given. It's not going to include the last number. We'll even say, but not include the last number. So, no, that's a lot. Let's just print it out. Take a look. So 1 to 3 will print The Hangover starting at 1, and The Perks of Being a Wallflower, which is 2, it will not print 3. Okay, so make sure you understand if you go 1 to 3, you're only going to include 2 items, not 3 items. Now, you can also do 1 to 4, which would print all of those. If you wanted to print everything from the beginning of a number, so say we wanted to print movies 1 and we wanted to go all the way to the end, we could just do something like this. We could start from a certain point in index, print The Hangover, Perks of Being a Wallflower, The Exorcist, and we're skipping When Harry Met Sally because we're not starting at 0. Okay? We could also do, in the opposite of that, movies. And remember, if we go to 1, it's not going to include 1. It's only going to include the first item here. Everything before. So When Harry Met Sally. Everything up until this point is another way to think about it. Okay? So if we wanted to print 2 items, we'd actually have to add a second or put the number 2 here, and that would include The Hangover. That's what we wanted to do. Now, another thing that we can do is if we wanted to print the very last item, we could do a movies -1. And you don't need to commit all this to memory right now, especially if you're not working with lists. But if you ever do work with lists, you need to pull specific items down from a list. This becomes very important. So it's important to know that indexes or indices exist. You start at 0 and then you move forward, and then the way that you can splice these just depends on how you call these. Now this will return last item in list. We save that, take a look. You'll see it'll return The Exorcist here. Now we can apply methods to lists, just like printing length of movies. We'll count the items in the list, right? In the list, and we'll save that. Just take a quick look. I never closed this, sorry. So you can see it tells you your mistakes, and even I make mistakes. Come in here, try it again. You can see that we have 4 items within our list. All right, so, and that is true. We have 4 items in the list. We can also add to the list. So we can use something like movies.append. We'll add to the list. And if we wanted to add the movie Jaws, we could. And if we printed movies, you'll see that this appends to the end of the list. Let's go ahead and save that. And you'll see now that JAWS is here at the end. Now, we could also insert a movie into the list. So if we did movies.insert and we wanted to put in a specific spot. So say we wanted to put it in index 2, we could say 2, and then we could give it a movie, Hustle, the movie I just watched recently and really liked. And we can come in here and print movies now. We save that. You can see that we can actually insert Hustle here into position 2 on the index. So pretty neat. Now we can also remove movies. We did movies.pop. Come in here and that will remove the last item. So if we come in here, add a print statement really quick, save that and then print this out, you'll see that JAWS is now gone. We can also specify specific spots we want to remove. So if we want to remove index 0, we could, and then this will remove the first item. Print movies, save, go ahead, and When Harry Met Sally is now gone from our list. We can also combine two lists. So if we come in here, and let's say that my wife has favorite movies, and she definitely does, and we'll just go with a couple of her favorite movies. She likes Just Go With It, and she also likes 50 First Dates. Come in here and close that off. Well, we can combine movies. Let's say we wanted to know our favorite movies. What we can do, we can combine lists, I should say. Come in here and I could say, I want to add movies plus Amber movies. And I can print our favorite movies. And then I have now combined lists. Let's go ahead and take a look at that. Hopefully I did it right. And you can see now The Hangover, Hustle, Perks of Being a Wallflower, Exorcist, Just Go With It, 50 First Dates. You could also just come in here, if you copied this, by the way, and just pasted this. You don't have to put it into a variable. You could totally do it like that. But I think storing in variables is a better practice. So I'm going to go ahead and just Control Z here. And one more thing. So we can also have what are called 2D lists. So two-dimensional lists. So let's say, for example, we have grades. And we have a list of grades, and we're going to say that inside this list, we have Bob, and his grade is an 82. And then we have Alice, and she has a 90. Okay, and then we've got Jeff. Jeff's not doing so hot. Jeff's got a 73. Okay, and let's say we wanted to pull down Bob's grade. We could make a variable, like, just call it Bob's grade, and we could set that to grades, and then do something like 0, 1, like this. And what are we doing here? Well, we're saying, I want to pull from the first index, okay, index 1, or 0, right? First index, 0, 1, 2. So I'm pulling from 0. And within that, I want to pull the second item, which is this, 0, 1. So we have a two-dimensional index here. And if we went ahead and printed Bob's grade, you can see now, if we save this, we get an 82. Well, that's correct. What if we screwed up Bob's grade and we wanted to fix it? Well, we could also do something like grades 0, 1, just kind of like we called, and we could just set it equal to 83. Maybe it was an 83. Okay, we come in here and we print out grades. You should see that this has changed. So let's go ahead and print this. You can see now Bob has an 83. So we can modify our 2D lists as well. So that is it for lists. Remember, lists have brackets. Lists are data structures. We can change lists. As you saw, we were able to append, pop, insert, remove. okay, we can modify many different ways. We're going to move on here in a second to what are called tuples, and tuples cannot be changed. Even though they look very much like lists, they are different. So I'll go ahead and see you over in the next lesson when we cover tuples. Okay, let's talk about tuples very quickly, and then we're going to move on. So do a new line, say tuples. And these are like lists, but they do not change. We'll say do not change, and then they get parentheses, as opposed to getting brackets. Okay, so we might want to have something that doesn't change. And when something can't change, we say that they are not mutable, M-U-T-A-B-L-E. They're not mutable. So that means that they're immutable. And tuples are immutable, meaning we can't change them. So we think of lists mutable, tuples not mutable or immutable. So if we have a tuple of grades, we can say something like grades are equal to A, B, C, this is the American grading system, D, and F. Come in here. If we did something like grades.pop, like we saw before, or grades.append, something like that, neither of these are not going to work. Or neither of these will work, I should say. Proper English. What's going to happen is they're not mutable. We can't change them. Once we have this and we store it, it does not change. So if we want something that is like a list, but we don't want it to change, it's better to use a tuple. We can set something in stone, like our grade letterings, and then we can call those when we need to. We can just say something like print grades and give it a 1 and save it, and we should get a B back. Okay, and we get a B back. So that's it. Just know the difference between tuples and lists, in that tuples do not change, but they are very similar in how they can function, and there are pros and cons to each of those. We're going to go ahead and move on to the next lesson, which is going to be looping. Okay, so let's come in here, make a new line, and we're going to call this looping. So we're going to talk about two different types of loops. The first type of loop that we're going to talk about is what's called a for loop. And for loops are start to finish of an iterate. And here's what a loop looks like, and we'll take a look. So let's go ahead and get a list. We're going to say vegetables, and you can put whatever vegetables you want in here. I'm going to go with a cucumber. I'll do some spinach, and then we'll do some cabbage as well. And now what we're going to do is we're going to come in here and we're going to write a for loop. We're going to say for x, and x could be whatever you want it to be. You could say for veggies. It could be whatever you want to call it. In this instance, I'm just going to call it x in vegetables. So for x in this list, we're going to go ahead and print out x. So what do you think this is going to do? All this is going to do is just loop through the iterates, start to finish of an iterate. So it's going to say cucumber, spinach, cabbage. Let's go ahead and give it a go, save it, print it. Cucumber, spinach, cabbage. All we did was go through a list, iterate through it until we reached the end of the list, and then it stopped. So that is a for loop. Another good example of a loop, if you want to think about it, might be trying to ping an IP address, so like a 192.168.1.1, or maybe you have 1.x. Maybe there's a whole slew of IPs that you want to ping. Maybe it's 1 through 254. Okay, if you wanted to ping all of those, you might want to do something like a for x in IP, and where IP is just equal to like a sequence. Like say IP is like a sequence of 1 to 254. And don't worry about this, I'm just logically writing this out. So if you say IPs 1 to 254 for X and IP, and then you want to do something, you might want to like ping 192.168.1.x. and then x will be 1, then 2, then 3, then 4. Okay, so you could write something like this for a ping sweeper. Again, it's a start to finish of an iterate, 1 through 254. We'll stop at 254 when the iterate is done. Now, another example of this, or another example of a loop, is what we call a while loop. Let me say while loops. These execute as long as true. I should probably capitalize true, so that way it makes sense that we're talking Booleans. So let's think about this situation. What about we set I equal to 1? So we've got a variable of I equal to 1, while I is less than 10. We're going to go ahead and print out I, and then we're going to say I plus equals 1. So what's going to happen? Well, while I is less than 10, so right now I is equal to 1, 1 is less than 10, that is true. We're going to go ahead and print I, increase the value of I by 1, so the next time it loops through, it's going to be 2, and it's going to continue on until this is no longer true. So if we save this, this should print out 1 through 9 because we're not looking for 10, just 1 through 9. So we're going to say that, hit enter, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it looks like the loop actually did its job. So again, we have two types of loops. All we need to know about right now is we have a start to finish of an iterate, that's a for loop. Then a while loop executes as long as true. We may see these later on as we do our project work, so keep these in mind as we go on through the course. So from here, we're going to go ahead and move on to advanced strings. So I'll see you over in the next lesson. Okay, let's take a look at some advanced strings. So if we come in here, again, we do a new line. So go ahead and enter advanced strings. And let's create a variable of my name. I'm going to say my name is Heath. Now, let's say we wanted to print my name and we wanted to grab the first letter of my name. How do you think we might do that? Well, if you're saying index of 0, you are absolutely correct. And we can say in here first letter. What about printing the last letter of my name? Well, if you say -1, you have remembered your index lessons. Great job. That's going to be the last letter. We can save this and we can go ahead and print. And if I made this a string, that would be very helpful. Go ahead and save this. You can see that we get the capital H and the lowercase h here because my name starts with an H and ends with an H. So, another thing to note about strings, much like tuples, they are also immutable. You cannot change a string. We cannot modify the string. We can join strings. We could split strings, and we'll talk about that here in a second. But once I have set this variable in this string is here forever. I can always change the value of this variable, but you cannot change this string. So again, strings are immutable. Now let's go ahead and say we have a sentence. And we give that something like this is a sentence. If I can type today. And we print out sentence with something like this. What do we think that's going to look like? Let's save this, print it. You can see that we get this. What are we doing? Well, we're just grabbing this first word. However, we have the benefit of knowing what the first word is and how long it is. So we went 0, 1, 2, 3. Remember, we stopped at 4, so we grabbed the word this. Well, what if we were in a situation where we didn't know what the word was or how long the first word was? We could use something like a delimiter. So we could say print, and we could do sentence dot split. And if we do a dot split, we can just do it like this. And then this is a delimiter. And a delimiter says we're going to take something and we're going to split based on that. Now the default delimiter in Python, if we just give it a split, is a space. So we save this, come in here. This is a sentence. Now, look at it, it's in a list. We could pull the first item if we wanted to and know the first word instead of having to split it like this or pull it out like that. So we could do something like this as well. This is just a proof of concept that's a little bit fun. We go sentence, split, and we say that is equal to sentence dot split. Okay, and then we also create another variable and we call that sentence join, and we say that is equal to space. We're giving it a delimiter to join on. Actually, we're telling it what to add in between the different words that we're pulling out. So we're adding a space here. And we're going to say join sentence split like this. And if we print out sentence join, what do you think we're going to actually have happen here? I'm going to save it. Guess what? This is a sentence. So all we did was deconstruct this sentence based on the delimiter. It came out to this is a sentence, and then we joined it back together with a space. So every one of those got a space in between, and that's it. So that's just a nifty little way to show you that splitting and joining is possible. And again, this is still immutable. Even though we're messing around with the strings are immutable. So let's take a look at a few other things here. I mentioned in the beginning of the first lesson when we were talking about strings initially that we might have different ways of using single quotes and double quotes. And think about this, like what if we had a situation of quote and we wanted to say something like, he said, give me all your money. Well, with this situation, what are we going to do? What if we wanted to add quotes here and say, give me all your money? We do that because that is a quote. Well, it looks like it's kind of messed up. We're not seeing it in green. It kind of looks funny. What we can do in this situation is we can use single quotes if we wanted to. Or we could flip this around, by the way. We could use single quotes on the outside and then double quotes on the inside if we wanted to use double quotes here. And I could save this. Let's print out quote just to show you, and then we can save this. Another thing that we can do, though, is we can say something like quote, and then we can just do he said, and we can do character escaping. So we can do give me all your money like this. And now Python knows that everything within these escaped characters is ignoring this double quote here and ignoring this double quote here. So we're escaping that, and then we can print it, and hopefully we did this right. Go ahead and print. You can see now it says, he said, give me all your money in double quotes, while we also use double quotes on the outside. So we can use character escaping if we want to. Just know that we'll have to use this backslash in front of each of the characters that we want to escape. Okay, let's take a few more examples here. So if we say something like a variable of too much space, what happens in a situation where we have, like, you can just add as much space as you want in here, it doesn't really matter. We have a string with a lot of space in there. Well, we can strip this out. We can print too much space, and then we can do a dot strip. And the strip is going to take the delimiter of a space as default. And that will also strip this out. You can see there's just hello there, nothing else. So that's kind of nice. A few more items. What if we have the letter of A and we have the word of apple? Okay. Well, what if we wanted to know something like this? Let's actually go up a little bit. And let's say we wanted to know, like, print A in apple. Okay, and what is this going to return? Go ahead and if I could type, sorry. And this is going to return something. Let's go ahead and save that. That's going to return true. So we'll just say true. Now if we print A in apple, you're going to see that this is going to return false. Save this. Why? Well, this here is a lowercase a, and that does not exist within apple. So even though we're looking for a specific letter within a word, we have to match case sensitivity in order for that to return true. So if we wanted to know if the letter A was in the word apple and we weren't concerned about case sensitivity, then what do we do in that situation? Well, this brings something up that we did a little bit early on, which is using lowercase. Remember the lowercase method. We can say print, and then we can come in here and say letter.lower. You could also do upper if you wanted to, but what we're doing is we're converting all of this to lowercase. So this is now going to be a lowercase a, and then we could say in word.lower, and we can just say this is an improved way of doing this. So if we print that out, we save this, this should come back as true. So think about when you're trying to match a word or a string or anything, and if somebody came in and you were expecting, like, I don't know, like think about school, and we're thinking about a word, maybe like Manhattan, I don't know, and somebody types in Manhattan like this. Okay, we still want to be able to accept that answer is true, even though they may have screwed up a little bit on the punctuation. Now, there could be instances where we want a capitalized letter and it has to be very specific. In that case, this kind of syntax works. But if we're looking to just accept an answer, like Manhattan for Manhattan, then we might want to consider using lowercase or uppercase in that situation just to match those words or letters or whatever it might be. So one more thing. Let's look at what is called string formatting. So if we do something like movie, we'll pick The Hangover again. We say The Hangover. You can pick whatever movie you want here. There's a few ways that we can print this out. Remember, we concatenated early on, and we said like print. We did something like my favorite movie is space plus, you know, movie, something like that, right? Well, we can actually write this in a certain way that is a little bit easier. So there's a few things that we can do. For example, we can do my favorite movie is, add a couple brackets in here like that, and then we can add period at the end just because we're going to close our sentence. We'll say dot format, and we'll say movie and close that off. That's one way of doing it. Okay, if we save that, you can see my favorite movie is The Hangover. Okay, this is called using the string format method. Now, what we can do, there's another type of method we can use, is we could say print my favorite movie is %s, and we say %movie, just like this. Save that. This is using % formatting, and look, the same thing happens. I just forgot my period in there, so no big deal. Lastly, if we print out an F in the front, this is called an F string, or what's known as a string literal. We can do my favorite movie is, and then just do movie like this. Super easy. And we have moved off of using the format method and the % method into this F string or string literal. And we come in here and save this, tab up, print, and you can see my favorite movie is The Hangover. So that worked out perfectly well. You can use any of these to format, but just know that the F strings are the latest and the greatest way of doing it in Python 3. So that is it for this lesson. We're going to go ahead and move on to dictionaries. Okay, so we'll add new lines in here, and we'll say dictionaries. And we can think of these as key value pairs. And also think of these with the curly braces like this. So we've seen lists like that, and we've seen tuples. Now we can think of dictionaries with the curly braces. So let's go ahead and we're going to put some drinks. And again, I'm going to use alcoholic beverages. You do not have to do that. You can use whatever drinks and prices in here that you want, but we're going to have a key value pair. So our key is going to be the drink. So first drink I'm going to pick up is a White Russian, and the value is going to be 7. Let's say that a White Russian costs $7. If we do an old fashioned, we're going to say that this costs $10. And we'll do one more. We'll do a lemon drop, and we'll just say that this costs $8. Okay, and we can make a note here to ourselves that drink is the key, price is the value. Remember, key value pairs, key value. All right, so we've got our drinks. We can print our drinks. Save this, go ahead, print. And you can see we print out our dictionary here. Now, let's give it another example. Let's say that we have employees. And this could be a good example. So we say we have employees, and I really like the show Bob's Burgers. So I'm going to use Bob's Burgers here as an example. Let's say we have different departments. We've got the finance department. And in the finance department, we actually have a list of people. What if we've got Bob, we've got Linda, and we've got Tina, all in finance. We can also have another department. Let's have IT. So again, that's the key, and the value is going to be this list that we're putting in there. So Jean, Louise, and we'll throw Teddy in there as well. And that one, and let's do one more. We'll do HR. So HR, and we'll put in here Jimmy Jr., and we'll also put in Mort. Again, you can put whatever you want in here, and if you need to pause, if you're trying to follow line for line, word for word, you need to pause and type this out, feel free to do that. I'm going to go ahead and print out our employees just to show this. Make sure I type this all right because this is a lot of syntax. And we've got finance, IT, and HR. Looks like we did a great job. Awesome. So let's say I wanted to add a new key value pair. I could do that in a couple of different ways. We can do something like employees, and we can just say something like we want to add a legal department. All right, and in the legal department, we're going to have just one person. We'll just have Mr. Frond. He's our legal team. Okay, we'll just say adds new key value pair. Save that. Actually, let's print employees so that way we can actually verify. Save, print. And you can see legal adds Mr. Frond. So we are adding to the end of our dictionary, just like we added to the end of our list. Everything gets appended to the end unless we specify otherwise. Let's go ahead and come in here. Another way that we can do this is we can say something like employees.update, and we can say something like give it a sales department. And in the sales department, we'll have Andy, we'll have Ollie. Close that off. We're also going to have to close off our curly braces, and we'll close off our parentheses. And if you have a decent notepad, it'll show you where your items are, so that way you know you're closing things off correctly. So we've got 3 different types of syntax going on there, and it sometimes can be hard to read. So here we could say adds new key value pair as well. So just another way of doing it, we can print employees, and we'll see that Andy and Ollie should be added provided we typed everything correct, which we did. So here's sales with Andy and Ollie. Okay, one more thing. Let's say that we wanted to update something in our dictionary. We're going to go ahead and update a value. We're going to go back to drinks for this one. Let's say that inflation has happened, which it has. And with inflation, the price of a White Russian has now gone up from $7 to $8. We can do something like that, print drinks, and you should see that hopefully this has been updated to $8, which it was $7 before. Now it's $8. Perfect. We can also grab the value of that. So if we wanted to do something like print drinks.get, and then we do White Russian, we could totally do something like this and save, and hopefully it will return 8. And it does. So that is it for this lesson. We're going to go ahead and move into a new file here in the next video. So let's go ahead and save this and close this, and we'll prepare for the next video. So I'll catch you over in the next lesson. Okay, so I wanted to talk about importing. We're going to talk about importing modules. So I wanted to make a new file for this. Let's just call this mousepad importing.py or whatever you want to call it. And I'm going to do the ampersand here. And again, if you're using Windows or Mac, just make sure you create a new file for this. I'm going to go in here and I'm going to add my shebang like before. I'm going to declare bin python 3 and save this. And now we're going to go ahead and talk about importing. So importing, let's type this, importing. And we'll say importing is important. Now, modules exist within Python that are built in but not available to us without importing them. So like you saw us being able to do math, but we could import a more robust module of math and then use that to do more advanced calculations outside of adding, subtracting, exponents, etc. In this instance, we're going to talk about a couple of different imports that we can do and that you're going to see again as we get into some of our hands-on stuff and we build out some projects. For example, we might want to import something called sys. Now, let's say if we tried to print out sys.version, and we'll just save this, and then we're going to python 3 importing.py, and you're going to see that I get an error back that says sys is not defined. Name sys not defined. Okay. Well, sys is something that we're going to use quite often in Python. You're going to see it imported quite a bit, and it does a lot of different unique items. Like it does something called argv, for example, which we'll use as an example later on. But if we want to specify an amount of arguments, say we're trying to run Python 3, well, we're going to do a port scanner later, so we'll just say port scanner.py, and we need to supply an IP address here, right? And this is argument 0, this is argument 1. So if we supply no argument 1, then we're going to throw an error. It's going to be an if-else statement, and that's going to use something called argv. Now, we'll get into that later, but that's very important, and it's a part of sys. Another part of sys is doing something like the version type of Python that we're using. Or another thing is the sys.exit, which you'll see later on as well, which is going to allow us to gracefully exit when we encounter an error, we tell the script to exit, or whatever we're doing. So we might need to import something like sys, or another one is os, which is very common to be imported as well. So let's talk about importing. In order to import, we can say something like import sys, just like this. And we can just say this is for system functions and parameters. Save that. And let's go ahead and just print this now and see what happens. You can see now that sys has been imported, even though it wasn't built in automatically, we can import it, and you can see now it tells us, hey, we are running on version 3.10.5 of Python, and it was downloaded on June 8th, 2022, or built on June 8th of 2022. So from here, let's go ahead and import something else. Let's go ahead and import date time. And we can import from something. So I know this is going to be confusing, but we can import specifics from a module. So we're just importing the date time feature from date time. Even though they're named the same, just know that we can import specifics. We don't have to import the whole thing, even though we totally could just import the whole thing as well. So here, for example, we can say print datetime.now like this. And you know what this is going to do? It's going to tell you what the date and the time is. And I apologize, this is backwards. It's from date time, import date time. So again, your syntax will tell you where it's wrong, and it is perfectly normal to make mistakes. I leave these in the videos so that you see that I am human too, and it's completely normal to make mistakes like this. So go ahead and do your script now, and you'll see that it gives the date and the time. So right now it is July 6th and it is 2 o'clock in the morning. I am a night owl. Now, one other thing that we can do is we can come in here and we can, from datetime, import datetime. And we can also give this an alias. We can say as DT. What if we don't want to write datetime out? We just want to do DT. Just like we didn't want to write new line out, we did NL. Same kind of concept. So we can just say import with alias. And instead of saying datetime.now, we could just say dt.now. Save that. Go ahead and print it. You can see it still works. So absolutely the same thing. We're just giving an alias, making it a little bit easier to run. Okay, so that is it for this video. Let's go ahead and close this out, and then I'm going to meet you in the next video when we're going to talk about sockets before we get into building out a port scanner. So I'll catch you over in the next video. Okay, so let's make a new file, and we're going to call this s.py. And again, create this however you want to. If you're using Linux, you can follow along like this, or just create a new file in Linux or Windows. Again, we're going to shebang this up here. I'm going to give this a bin Python 3. Now, this isn't incredibly necessary if you're running on Windows or Mac, but this is just best practice for me. This is the location of my Python. Even though I'm not actually calling it, I am calling it with Python 3. So this isn't incredibly relevant as long as you're using Python 3. Now, we are going to deal with sockets. So sockets. Now, sockets are what can be used to connect two nodes together. So we're going to use this to connect to ports and IP addresses. If you're unfamiliar with computer networking, that's okay. But what we're looking for is a port, and we're going to look for that port on an IP address. And on that IP address, if that port is open, we're going to make a connection to this. We're going to build a port scanner in the next video or later on in the lesson, and you'll see this in action. Right now, I just want you to notate, understand what we're doing, and then I'm going to demonstrate an example that you do not have to follow along with, and you might not be able to follow along with. So that's okay. But just know that sockets are used to make a connection between ports and IP addresses, and you'll see that here very shortly. So you do not name this, by the way, socket.py. If for some reason you came in here and you named this socket.py, this will break Python because we are going to import socket. So make sure that you come in here and you rename this if you named it socket.py. It's very easy to do that, but that will break the socket.py, which is what we're importing here. So with this, we're going to set a couple of variables. We're going to say host is equal to 127.0.0.1. And this is our loopback address or our home address. If you're not familiar with computer networking, I do recommend that you go take a class on computer networking because it will become very important as you get into Python development, especially if you ever work with nodes of any sort. So other thing is ports. So we have ports on our machine that we can connect to. We're going to be using TCP. If you do not know what TCP is or what the ports are, that's okay. You can still follow along, but know that there are 65,535 available ports. Some ports are very common in what they use, like port 80, for example, is a web server over HTTP. You have 443, which is HTTPS. 21 is FTP. There's a lot of common ports and protocols that are out there. We're going to pick a non-standard port, non-common. We're just going to say 7777. So what I'm going to tell this to do is I want to tell this to reach out to this host, which is just going to be us for this example, and this port. I want to make a connection on this port. Now, I'm going to give a variable of s, and this is going to be a very long statement. So if you say socket.socket, I'm going to type this out and then I'm going to explain everything, okay? So socket.af inet, then we're going to say socket.sockstream, and then just for your notes, AF inet is IPv4, sockstream is a port. So we're giving it this S because we are not wanting to type this whole long thing out all the time. We're just shortening this. What we're going to do is we're going out to make a connection to this AF inet, which is IPv4 IP address, which is what this is. And we're going to also make a connection on a port, which is our sock stream. We're going to give it this port. We're going to say that by doing s.connect. And we're going to come in here, and this is going to be a tuple. So we're actually going to use double parentheses here, host port. Okay, and we could come in here, by the way, and we could just put in 127001 instead of using a variable. But I like to use variables because it's best practice, but you could hard code this in if you wanted to. But here, I just like using the variables. Easier to change, especially if you're coming in here and you're writing in a bunch of host port calls to the variable. It's easy just to have it in one place as opposed to hard coding this. Okay, so I'm going to go ahead and save this. This is where I do not expect you to follow along because you might not have the architecture behind it. Now, as I stated in the beginning of this video, I am an ethical hacker by trade, which means that this version of Kali that I've been running on, or this version of Linux that I've been running on, is actually Kali Linux. And in Kali Linux, we have a bunch of tools available to us for pen testing and ethical hacking. One of those tools is a tool called Netcat. Now, Netcat is NC, and basically what it does is allows us to connect to open ports or establish a listener on an open port. So what I'm going to do is actually I'm going to open up a new tab here, make this bigger, and then I'm going to run this here. Just understand, if you've never used Netcat before, that's fine. I'm just opening up a listener on a port. That's all. Just worry about the L and the P for now. Listen on port 7777. Anybody makes a connection on that port, we're listening. So we are going to connect to ourselves because we wrote the script out to 127001, which is us. And all we're going to do is Python 3 s.py, hit enter. Nothing's going to happen. We don't have any print statements, anything crazy. But you can see that a connection was made from 127001 to 127001. And it made a connection on this port, and we connected on the other side on this other port here, which don't worry about that too much. If you're not familiar with networking, that's absolutely okay, but there has to be two ports being connected, one on one side, one on the other. So here, we made that connection. We didn't tell this to do anything else. We just said, hey, go out, listen for this connection. We made a connection, we established it, we did our job, we used our socket, and we are good to go here. We closed the connection because there was nothing, no instructions given or anything else. And that's all we needed. So what we're going to do now is we're going to, in the next video, build out what I call a terrible port scanner. And we'll talk about why it's terrible, but we're going to tie everything we've learned so far together and build something out that is actually usable with Python. So been throwing all these lessons and terms and everything out to you. Now we're going to apply that. And you're going to see how we can use that all together. And I'm very excited. So I'll catch you over in the next lesson when we start building out a port scanner. It is time to create our first project. And this project is going to be building out a terrible port scanner. And so let's go ahead and create a new file. I'm going to call this scanner.py. Give it the ampersand here if you're on Linux. And then we're just going to call this then Python 3, save it, get the pretty colors going. And what we are going to do is we are going to create a scanner that is going to be something like this. We're going to type in Python 3 scanner.py, and then we're going to say IP address. We want to provide an IP address, and then it's going to go out and do port scanning on that IP address. So hopefully we can build that out. For now, let's go ahead and import a couple of things. I should say a few things. We're going to import sys, talked about sys. We're going to import socket, talked about socket. And from datetime, we're going to go ahead and import datetime. So none of this should be new to you. So first thing that we're going to need to do is define our target. So we need to set up an if statement. I'm just going to say define our target. And what I want to say is if the length of sys argv, and I'll explain this in a second, is equal to 2, then we're going to set a target variable. Target is going to be equal to socket.getHost by name. And we're going to say sys.argv1. And all this is going to do is translate host name to IPv4. All right. Let me make the else statements. I'm going to come back. I'm going to explain everything, okay? So if we do else, we're going to print out invalid amount of arguments. And also print out syntax Python 3 scanner.py IP address. Something like that, okay? Go ahead and close that off. Okay. So we're taking a method of length and we're saying sys.argv. We spoke a little bit about argv in the importing section. Argv is going to be the amount of arguments that we are giving. So when we come in here and we type in Python 3, okay, our first argument, argument 0 in theory, is going to be scanner.py. The second argument, or second index, index of 1, is going to be the IP address that we give. So 192.168.1.1 or whatever it might be. So we need to have 2 arguments. If we have a third argument, it's going to break. If we don't have a second argument, it's going to break. If we just type in scanner.py, it'll break. If we type in an IP address, like 1.1, and then we type in something here, it's going to break because there's too many arguments. So if it doesn't meet this specific length, then what we're going to do is print out invalid amount of arguments. Here's the syntax. Give somebody some help here. If it does meet the length, then what we're going to do is we're going to set our target equal to socket.getHost by name. And all this is saying is we're going to get host by name of sysargv1. That's our IP address. Now this is going to translate a host name to an IPv4. So in case, for example, if you did Python 3 scanner.py and you had a host name like I have a host in my house called Punisher. Like if I gave it Punisher and my DNS knew internally that that translated to a specific IP address in my network, that's fine. This will translate. Okay, easy enough. But we could also just give it an IP address. So that's what we're looking for here. I highly recommend for this example using an IP address. In previous lessons, when I've taught this before, somebody has tried typing in a host name and it doesn't always go as planned, though we will talk about adding error exceptions for that here in a little bit. So right now, all we need to know is we're trying to set this up with these arguments. Now, this is not the best logic. This is something that will work for our needs because we are building this out. But if we're building this out for somebody else, this logic's not great. And this is why I call this a crappy port scanner, is because it's not the best. We're only doing it for proof of concept and to learn what we've learned so far. But think about this in another way. Think about if we're running two arguments. Well, I could give this an argument. What if I come in here and I say Python 3 scanner.py, and I give it the second argument, but I give it like 192.1 or something like that. Well, that's not a host name. It's not going to translate to anything. That's also not really an IP address. So we should really add some other statements in here to say, hey, it needs to be a valid IP address. It needs to be like have 4 octets like we expect. And if we really wanted to get critical about this, we can make sure that it is a valid IP address, because IP addresses can't start with like 256 dot whatever. So we could say it must be between each octet must be between 1 and 254, and get really refined with that and say, hey, that's not a valid IP address, thus we're not going to scan this. But we don't have to worry about that right now. I'm just saying the logic behind it, we need to start thinking about, well, how can a user break this? We know how to run it, but if we gave this to somebody else, how would they run it, and how could they break it, or how could they typo something? So these are things to think about as we go. So for now, we've added this in. We've got this in here. We could test this if we just save it. We come in here and we just say Python 3 scanner.py. We don't give it any arguments. You'll see that it says invalid amount of arguments, Python 3 scanner.py is the syntax. Perfect. Don't give it an argument right now because it's going to break if you don't have DNS translating properly. So from here, let's go ahead and add a pretty banner. So just add a pretty banner. And all I'm going to do is do a print command. And I'm going to just do a bunch of dashes. This is not really going to be that pretty of a banner, but it's still going to be a banner. And so when this kicks off, if we've got a valid IP that we're going to be scanning, we're just going to do scanning target, and then we'll just do a space. And you could just do a concatenation here of plus target. You could do F string if you want. Completely up to you on how you want to do this. So we just do scanning target plus target. This will say what the IP address is. We can do like scanning target of that, something along those lines. And then we could say print time started. And then we can give this something like a string. So we want to give plus a string of date time dot now. Remember, we can't concatenate numbers and strings. So we're going to go ahead and do this. And then we'll just print out this one more time. Okay, I'm going to save this. Let's go ahead and try running this with like, I don't know, 192.168.1.1. Okay, so this is what we get. We can see that we have scanning target. Okay, scanning target 192.168.1.1. Here's the time that it started. Perfect. We've got a pretty banner set up. So now let's actually start making it do something. So we're going to use what is called the try command. We're going to try something, and if it works, perfect. If it doesn't, we're going to have exceptions for that. So here's what we're going to do. We're going to say try for, we're going to do a for loop, port in range. Remember we talked about a range earlier. We talked about, well, what about a for IP in range of 1 through 254? We're doing the same concept here. Now we're just giving it a range. Now there are 65,535 potential ports. I'm not going to force you to scan all those. If you want to, you can come in here and say 65,535. This is not threaded. We are not doing any sort of speed runs here. This could potentially be a slow port scanner. So it is best, in my opinion, to do like a port scan between 50 and 85. And the reason I do this is because we're going to scan or attempt to scan our home router, and usually DNS is open on that. and usually port 80 is open on that. So I'm trying to look and see if we can find a couple ports that might be open. So for port in this range, what we're going to do is we're going to set our S equal to that lovely socket.socket, socket.afinet, and socket.sock_stream, just like that. And then we're also going to come in here and we're going to do a socket.set default timeout to 1. So if it responds back or doesn't respond back within a second, we're just going to move on. We don't want to stick to scanning a port, waiting for it not to respond back to us, and then the script takes longer and longer. So we just want to make sure that we set our default timeout to 1 there. And then what we're going to do is we're going to go ahead and set a variable of result. And result is going to equal to s.connect_ex. And I'll explain all this in a second. Target and port. All right. So what this is doing here, actually, let me type out the rest and then we'll go back. We're going to say if result is equal to 0, we're going to print out port. We can do is open. So now we can come in here, we can do a format port if we want to. You could use an F string here if you want to. So we can just use an F string. So I'm just showing you examples, but you can say port and just do an F in front of this. Okay, port, whatever is open, and then we're going to close the connection. All right, let's read through this, make sure we understand what's going on. So we're going to do a for loop for port in the range of 50 to 85. So we're going to start with 50, then 51, then 52, go through that process. We are setting a variable of s equal to this because we're going to gather the IPv4 address and we're going to gather the port that we're trying to connect to. Now, our IPv4 address, here's our tuple right here. We are saying I want to connect on target and port. Target is going to be supplied by us. We're going to use argv1. So we're going to supply the IP address and the port is going to be this range here. So for port in range, we're declaring port here. Now this s.connect_ex, this is an error indicator. So if a port is open, the error result returns 0. If a port is closed, it returns a 1. So if the result is a 0, we're going to say, hey, this port was open. If it's not, it's going to close out and we're going to close this. Then we're going to go back to the loop and come through and try it again. So we're going to close out our socket connection on that port, come back, try 51, 52, etc., etc. Now, before we run this, there are some exceptions that we need to consider. So the first one, we're going to try this, but we need exceptions. So except, what if we have a keyboard interrupt? So we'll say keyboard interrupt. And that just means what if we hit Control-C while this is running? We can stop this on our own. So we're providing an exception of a keyboard interrupt, and we're going to say exiting program on a new line. And then we're going to sysexit. Remember, I talked about sysexit, and we're going to allow us to exit gracefully. We can also do an exception of a socket.gai error. Now this is what happens when the hostname does not resolve. So what if we say hostname could not be resolved? So if we typed in a bunch of mumble jumbo up here, we say like Python 3 scanner.py, and we just typed in something and that doesn't resolve to an IP address. Well, guess what? This is going to throw an error now, and we can exit. We got to cover all of our bases. Lastly, what if we have a socket.error? So we have an error when we're doing this, and we print out, hey, we could not connect to the server. It's just not online. What if we try to connect to an IP address and it doesn't talk back to us? but not connected to the server. So something to think about there. Again, we'll sys.exit. So let's go ahead and save this. Now, you're going to need to run this against something. So I'm going to show you an example of mine. Okay, so in order to run this, we need an IP address. Now, if I type in ifconfig, I'm actually on a virtual machine right now. So 192.168.138.140 is not my true IP address. I'm actually going to bring up my Windows machine that I'm on. And you can see here that I have a default gateway of 192.168.4.1. So make sure you know your gateway or what your router's IP address, or that you have a machine that you can scan that you know might have a port of 53 or 80 open, or you need to modify your script to make sure that you can scan for something. But I'm going to go ahead and scan my 4.1 because it should have some stuff open. So if I do a Python 3 scanner.py, and I'm going to come in here and just do a 4.1, and I hit enter, this could take some time. So what I'm going to do is I'm going to let this sit here. Actually, it's zooming through. You can see it found port 53 pretty quick. And then this might take time to find port 80 if port 80 is open. But basically what it's going to go through is go through port 50, 51, 52, 53, all the way through the process, and has that 1 second timeout as it goes through and checks each and every one of these ports. So it should take maybe up to a minute for this to work. So I'm going to go ahead and pause right here. Looks like we're almost done, actually. Port 80 came back as open too. No need to pause. It finished while I was yapping. So you can see it came back and said port 53 is open. Port 80 is open. So our script worked. It took forever to scan these ports, but it is working. So we were able to build out, let's go back and look at this. This is awesome. We were able to build out a port scanner that came in here, and within 2 hours, you now have the knowledge to build out a basic port scanner. You didn't think you would be able to do that. Well, here you are. Look at you. You're awesome. Okay, so we were able to give it an argument. We set our if conditional statement, make sure the length of the argument was 2. Valid. Otherwise, we have an else here. We made a little pretty banner. We imported some stuff. Got that all working. We did a try statement, which really was just a for loop in here. And we had some logic based on conditions that would happen within this for loop. We had a for loop and an if statement together. We used a f string to print this out. Pretty cool. Came through. We had some exceptions as well. For example, like the keyboard interrupt, just as to show you, if I come and run this again, if I wanted to stop this scan in the middle of it, I could just hit Control-C and it'll say, hey, exiting program. And that's exactly what we told it to do. So you could say in here, it says exiting program. So that's the keyboard interrupt. Same thing, we had exceptions for not being able to connect, or we had the host name could not resolve. We would also have those sorts of things as well. So you could test out those errors, see if they work for you. But other than that, we built a scanner. So this is project number 1. We're going to go ahead and move on to learning a little bit more Python, and then we'll go ahead and get into some more project work. So I'll see you over in the next video. Now we're going to take a look at accepting user input in our program and then how we can manipulate data with that input. So let's go ahead and make a new file. I'm going to just say mousepad, and we'll call this input.py. And I'm going to bring this over. We'll give this the shebang. Bin Python 3 here. Save it, get the pretty colors. And in order to take input in Python, all we actually need to do is just use input. Something like this. So we could say like, enter your name for input like this. And put a space. And we'll need to put this into a variable. So if we come into the front of this and we just say name is equal to, we could do something like that. And then we can just print out like hello and give a space, do name, and then we'll add an exclamation at the end or a period at the end. Doesn't really matter. And then we can just come in here and save that. And if we run this, close this out. I forgot to add an ampersand, so we'll do that real quick. And if we run this now, we just say Python 3 and we say input.py. .py, I'll say enter your name, I'll just say Heath, and you can see it says, hello Heath. We can add upon this, we can say like, what's your favorite drink? So if we just make a variable and we call it drink, and we do input and say, what's your favorite drink? And do a question mark, something like that. We can come in here and then just add upon this if we want. We can just say, have a space plus drink plus period. All right, and it should say, welcome Heath, have a, and then whatever drink we put in here. So if we save this, come back and run it. Okay, I'm gonna put Heath as my name, and then White Russian is my favorite drink. And it says, hello Heath, have a White Russian. So we can easily accept input like this. So let's think about if we wanted to build out a calculator. I'm gonna go ahead and delete this. What if we wanted to take input and make a mini calculator? We could definitely do that. So what if we had two numbers and we've been taking X and Y? So if we said X is equal to input, and we'll just say, give me a number, and then we'll do something like that. And then we can also do Y and also make that input, give me yet another number. You put whatever you want here, by the way. And if we do something like print X plus Y, and we do that, let's save it, and let's see what happens here. So I'm gonna print this out. We'll give a number, we'll do 3, and then we'll do 2. And it gave us 32. Why is it doing that? Well, what it's doing is it is taking these and giving this to us as a string. So we need to either do an integer here and put this in an int, or we need to take this as a float. So if we think about this from the past, if we want to only take integers, we can, but if somebody were to put in like 8.7 or some number here, and they gave that to us, well, we would only take the 8 and we would leave off the 0.7. So I think if we're building out a calculator, it's better to use floats. So we can just come in here and say float, and we'll put this all in parentheses, and then we'll do the same thing right here. So now when we come in here and we save this and run this again, what should happen is this should work properly. So if we did like 3 and then 3.2, you'll see that we get 6.2, which is proper. That's awesome. Well, what if we wanted to build this out further? We could make this into a situational thing. What if we not only wanted to do an addition, but what if we wanted to allow the user to say, I want to add or subtract or divide or multiply or maybe use an exponent? We could do that. So what if we added another variable and we just called this O for operator, and we just took that input and we just said something along the lines of input, give me an operator, right? And maybe we put this in the middle here, so that way we're not just getting two numbers. Maybe we want to take that and we want to say something like this. So that way it'll say, give me a number, give me an operator, and then give me another number, and we'll print that out. So now let's think about how we want this to flow. If we want this to work with a addition like we already have, we might want to come in here and just say something like if O for our operator is equal to a plus sign, well then we'll come in and just print out X plus Y. And remember, the indentation is important here. Else if, or elif, O is equal to a minus, guess what? We're going to print X minus Y. And we can continue on here. Else if O is equal to division, we'll divide, and then we'll multiply as well, so X divided by Y. Else if O is equal to multiply here, we'll go ahead and multiply that. Let's throw in an exponent for good measure. So let's do elif O is equal to an exponent. That's 2. asterisk there, and then we'll just print out x times y. So we've got a mini little calculator here, and we need to end this with an else statement. So what if we take input that doesn't belong here? If it doesn't match one of these operators, then we can just print something like unknown operator. All right, and just put a period there, save that, and this should work. So let's go ahead and give this a try. What if we come in here and we just say, give me a number, we'll do 3, and let's say we want to multiply, and we'll do by 3. And we get a 9. We can do it again. We can try something like, we'll do 4, and this time we'll do an exponent, and we'll do 4. So 4 to the 4th power is 256. So we have just quite easily built out a little calculator that we take input from a user and then utilize that to calculate that expression given what is given to us by the user. Now let's think of something else here, just as an aside. What if something is written differently? Like when I think of math, with Python, yes, we think of 2 asterisks as an exponent, but what if we had a situation where we wanted to maybe use the up arrow or the caret symbol, which is how I've commonly seen it used online for math and exponents? Well, we could do something like or O is equal to the up arrow like that. And what if we save that and ran this now? And if we gave a 4 to the up arrow of 4, guess what? We still get 256. So we can use our statement like that here, our and, or other operators that we have learned along the way. So start thinking about it like that. As we start to piece these things together, we're starting to build out little projects, and we can use some of the logic that we have already learned throughout this course. So that's it for this lesson. We're going to go ahead and move on to the next one. Okay, now we're going to talk about reading and writing files using Python. So let's go ahead and make a new file. I'm just going to mousepad, and we're going to call this file months.txt. And in here, let's go ahead and just type out the months. So we'll do January, February, March, April. If I could type, May, June, July, August, September, October, November, and December. If you need to take a break and catch up, go ahead and do that. Save this, and once you have it saved, go ahead and close the file out. So let's go ahead and create a new Python file. So we'll call this mousepad, and I think we'll just call this readwrite.py. I'll do the ampersand here. And for this, what we're going to do is we're going to go ahead and look at how we can read and write files. So the way that we do that is with the open command. So we'll say something like open, and with open, and actually let's add the shebang up here really quick in Python 3, save it. And with the open command, we can say something like open months.txt. And I need to add this here. So if we open months.txt, what we need to do with this, or what we typically do with this, is we store this within a variable. So we might just call this months equals open months.txt. And if we want to read that file, we can come in here and just print out months. And you'll see what this does here in a second. Now, best practice says to also close this out anytime we open this. So I'm going to go ahead and just add some lines in here because we're going to add some more stuff to this. But we can just do months.close. And we'll save this. Let's go ahead and run and see what happens here. So if we do Python 3 readwrite.py, you'll see we get this information back. Let me move this so it's readable. And what this tells us is, hey, this is the name of the file. We're in a certain mode, and this mode currently is read mode. And we get the default encoding here of UTF-8. So we're getting information back. We're not actually reading the file that we wrote. So some of the information that we can get, by the way, we can come in here and we can say to ourselves, well, is this file readable? So we have mode equals R, and this is one way to check it. There's a couple ways that we can check it as well. We can print out months.mode, and that will tell us what mode we're in. We can also print out months.readable, and that should give us a Boolean statement, whether that is true or false. So if we come in here and we save this, and we do this again, you'll see that we get months. We print that out. We get the whole shebang here, and we get the mode is equal to R, which is readable. You can see if we print out the mode, we can also see it's readable. Or if we do months readable, we can see that it is readable. So we have the ability here to actually print this out and read this file. So how do we do that? Well, let's go ahead and delete these two lines. And we can just come in here and do months.read. If we do that, what happens here? Let's save it, print this out. And you can see that it reads through every single iteration, January all the way through December. Perfect. So we just read a file and we closed out, working as intended. If we wanted to read this line by line, we could. We can do months.readLine like this. And if we save that and print, we will read literally one line. If we wanted to read a second line, we could copy this and we could paste this and save it and come in here, and guess what? We'll get January and February this time. So if we want to read this, we have to read line by line. Now, if we wanted to read all the lines at once, we could do that in a different way. We could do that with read lines. And this will print out an empty array or a list here, actually. And what you'll see is we get January, new line, February, new line, March, etc. So we put this into a list. And now, if we try to actually run this again, let's actually tab over. If we tried to run this twice, look what happens. I'm going to print this and save this. So we have the first list here, and then we have a second list here. The second list is empty. Well, that's because we've actually already read this. So we read through it here first, and then it's empty the next time we try to read it. So if we wanted to read it again, what we need to do is actually use what is called the seek method. We can come in here and say months.seek, do 0 like that to go back to the very first line, and print out again. And now you can see we actually printed this out twice. So that works out well. We also have the ability to put this into a for loop to read through every iteration of the line. So if we wanted to do something like for month in months, we could just print out month. All right, and that should iterate through everything in here. So save that, print this. And you can see that it indeed does print through everything. We can also add the dot strip at the end of this. Save that, print. And you can see that we strip out any of the new lines that are in there. So you saw we got some spacing in here, a little funky. So if we came through and we just added the dot strip, that makes our for loop a little bit better. So again, remember, what we're defining here is whatever we want. We can call this for X in months, make this an X, and it's the same thing. But logically, it's just easy to call this month in months, and then we can just print those out. So we can iterate through this. So far, up until this point, all we've done is been able to read a file. What if we want to write to a file or append to a file? Well, we can do that as well. So if we wanted to, for instance, open a file, let's open a new file. Let's do something we haven't created yet. Let's do days of the week. So let's do open days. And if we try to do this, let's change months to days. And we're going to change days to close, and we're just going to leave this open right here so we have our best practice. Now, if we tried to run this with an open days.txt, we're not going to be able to do that because currently we're just in read mode. So we want to be able to turn over and put ourselves into write mode. In order to do that, we can just do a W. If we wanted to check that out, we could just do print days.mode like we saw before. Make sure we are actually operating in write mode. So if we save this, you'll see that we are in write mode. So we're good to go. You could also just, again, delete this, save, and print out days. Apologies. You print out days, save that. You'll be able to see that we are also in write mode. So both of these work. Now let's write to a file. So we've got days. Let's go ahead and write to that. So we can do something like days.write. And let's say we wanted to put Monday into days. Save that, close it. And if we go ahead and execute that, nothing happens. But if we go ahead and cat out days.txt, you'll see that Monday has been put into days.txt. Perfect. So now, what if we wanted to continue on with this? Let's put Tuesday in there. And we're going to need a new line. So let's go ahead and do a new line with that. And we'll do Tuesday. And hopefully when we write this out, we'll see Monday and Tuesday. So let's save that. Print this. Sorry, let's run the script and then print this. And you'll see we have the new line in there and we have Tuesday, but we actually overwrote it. We don't have Monday anymore. So what's happening here is we're actually writing to a file, which is overwriting the file. We're not appending to the file. So if we wanted to append to the file, what we need to do is change this W to an A. And we can come in here and we can write in Wednesday if we wanted to. Save this. And now run this and run that. And now you can see we have Tuesday and Wednesday. So understand the difference between R being read, W being write, which overwrites, and A being append, which allows us to append a file instead of overwriting a file. So that is it for this lesson. I'll go ahead and see you over in the next one. All right, let's talk about classes and objects. So Python is what is known as an object-oriented programming language. So pretty much everything in Python is an object. And we can use what is called a class to be what is like an object constructor. And we can use that to help create objects. And this is a little bit easier to explain once we actually demonstrate this. So we're going to create a couple of files in this lesson. And the first thing that we're going to do is we're going to do a mouse pad, and I am going to create a file called employees.py. And in this, we're going to go ahead and declare a class. I'm going to save this here. So let's do class employees, save it. And we're going to go ahead and hit enter and just tab over. And we're going to do this define and 2 underscores, init or init, 2 underscores again. And we're going to put some parameters inside of this function. And we'll talk about what the init function is here in a second. Let's go ahead and let's think about having employees. So the first parameter we're going to define is called self. And then for our employees, we might want to know the employee's name. We might want to know what department they work in. We might want to know their role in that department, their salary, and maybe the years that they've been employed. So we'll do years underscore employed. And just like a function, we'll add the colon here at the end. And we're going to go ahead and tab. And then we're going to define all of this. So let's go ahead and say self.name is equal to name. So we're creating methods here, which you'll see us use in just a bit. We're going to do self.department equals department. And you should get the gist at this point. Self.role is equal to role. Self.salary is equal to salary. Self.years employed is equal to years employed. Okay, so let's save that. So all classes have a function called the init function, and this is always executed when the class is being initiated. So we're going to use this init function to assign values to object properties. So what we're doing here is we're creating these parameters within this function, and we're also building out methods that we can use once we import this class. So let's go ahead and close this out, and we're going to open up another mouse pad, and we'll just call this something like our employees.py. You can call it whatever you want. And I'm going to go ahead and do my shebang at the top. We'll do bin python 3. Save that. And from here, I want to actually import the class that we just built. So what I'm going to do is I'm going to import this, and we're going to say from employees, import employees. All right. And we can make a couple of employees here. So let's set a variable of E1 for employee 1, and we'll just do employees. And I'm going to stick with the Bob's Burgers theme from earlier. We'll just say we've got Bob. Remember, we're declaring Bob's name. His department, we'll say he works in sales. We'll say that his role within that department is the director of sales. And we'll say his salary is $100,000 a year, and that he has been employed for 20 years. And we'll do another employee. And we'll say that this employee is Linda. She is an executive. She is the Chief Information Officer, or the CIO. She makes $150,000 a year, and she has been with the organization for 10 years. So we can do some stuff with this. We can go and say like print e1.name. Let's save this, make sure everything works. Come in here. Actually, let me close and reopen this because I forgot my ampersand on this. And we'll come back, and now we'll go ahead and do Python 3, our employees. And you'll see that print e1.name is pulling down Bob. So we're using the name method that we created with our class. So we define that within that class. So now we have the ability to pull down information based on the class that we built. So we can also do something like print e2.role, and we should get that role printed out for us. So if we see e2 role, we're getting that she is a CIO. So that is accurate statement here. Let's see if we can open both of these. Let's open also employees.py, and we have both of these here now. So it's a little bit easier to see. We've got our function, our init function here, and we have all of our methods that we've defined. Now we can build upon this within this class. So let's say if we wanted to make another function, if we wanted to say something like define eligible for retirement, and we just said self in here as the parameter. What if we said something like if self.years employed is greater than or equal to 20, then we return true, because if the person has worked with us for 20 years, then they are eligible for retirement. Otherwise, if they haven't, then they haven't earned their retirement yet. So we can look at an employee and see how long they've worked with us, and we can save this here. And then we can come in here, we can do something like print, and we'll say E1, and we'll ask if they are eligible for retirement. Okay. Save this, print this out, and you'll see that Bob is indeed eligible for retirement because he has been with the company at least 20 years, which is what we put here within the class. So just know what we're doing is we're building out our own class, and we're able to define these functions and these parameters, and these help us with creating our objects that we're using over here. So we've got our classes, and then we've got our objects. So this can get really robust very quick, and we'll build out a project to look at that here in the next lesson, and that way we can tie this all together. But this is a very important part of programming, and this is very much a one-on-one class, so we're just skimming the surface on what this is. But this is actually incredibly useful when we start building out classes like this to help with other things that we're writing and pulling information from. So That's it for this lesson. We're going to go ahead and move on to the next one. We have reached the final project in this course, and this is going to tie everything together that we have learned thus far. So I am a bit of a sneakerhead, which means I really like shoes. And so what we're going to do is we're going to build a budget app using classes and objects, and we're going to see what shoes we can afford based on how much money we have. So we're going to go ahead and start with the class, and we're going to just make a new file. We'll do mousepad, and we'll call this shoes. I can type shoes.py. Open that up, and we'll also open up a new window as well, or just a new tab here, and we'll write in both of these. So for this one, we're going to go ahead and just define a class of shoes, and I'm going to go ahead and just save that so I see the colors. And here we're going to define our init statement, and we're going to just say self, and then we're going to have a name, our name of our shoe, and the price of our shoes. And within this, we're just going to define self.name equals name. This should all look familiar so far. And self.price is equal to price. What we're going to do with the price, because we'll run into an instance where this is going to be taken potentially as a string, we're going to go ahead and just give this a float. We want to make sure that we are assuming this is going to be a float of a price here. Let's go ahead and define a few more things. So I want to define a budget check, and I want to make sure that we have the budget here. So what we're going to do in this instance is we're just going to say self, and then we'll also add in budget here. And we'll come in here and we'll do a check first. We want to make sure that we are given an integer or a float here when we are asked for the budget. So we can say something like if not is instance. And what this means is we're saying if this type is not what we're specifying here, then we're going to go ahead and reject this and close out of the application. So the is instance looks for a type and returns a true value. But if we say is not true, then that's false. Remember our truth tables, and thus becomes invalid and closes the app. So what's going to happen is we're going to say budget, and we're also going to look whether budget is going to be an int or a float. And if it is not one of those two things, we're going to go ahead and print out invalid entry. Please enter a number, something along those lines. And then we'll exit the application. So let's say that we have a budget and we want to also know how much money is left over if we buy the shoes. So we can define something like change, or what change is left over. And we could say something like self budget on this as well. And we can just return our budget minus our self.price. So remember, we declared self.price up here. Now we're calling it and we're just saying, hey, I want to return the value of the budget that we have minus the cost of the item that we're purchasing. Okay, only a couple more things and we'll be done with our class here. So we also need to purchase it, right? So let's define buy, and we're going to do self budget again. And here we're going to do a self.budget check. And we'll check our budget. And what we'll say is if our budget is greater than or equal to self.price, then we're going to print out. We'll do an F string here, and we'll just say you can cop some, and we'll do self.name. So the name that we'll provide here. This will all make sense once we tie it all together. Okay, and then if our budget is equal to the self.price, then we're going to just say print out you have exactly enough money for these shoes. Otherwise, we can do else. Now we could go through this whole thing and give a statement and say, well, what if we had no money, or what if we didn't have enough money? But in this instance, we're just going to print out the situation of you can buy these shoes and have, we'll give a $sign here. We'll say self.change, and we'll give a budget left over. So we'll say left over, just like this. All right, and then when we exit the application, we can say something like exit, and we'll just give a statement, thanks for using our shoe budget app. Now, this might not make any sense yet, and that's okay. Let me make this a little bit bigger. And so what we're doing here is we're defining our init, and in our init we have a name, which is going to be the name of the shoe, and a price, which is going to be the price of the shoe. So self.name is equal to name, self.price is going to be a float because we're expecting, potentially it could be our price of our shoe could be $2.99 or $100.99. It might not just be a perfect number, so we want to use a float. We have our budget check here. We're just checking the is instance. We could, in theory, add to this budget check and make sure we have enough funding before we come down and do the purchase. Would probably be the logical way to do this. But in this instance, we're just using really beginner logic, and we're just coming through and we're just saying, hey, if this instance isn't an integer or a float, like somebody types in a string, then we're just going to go ahead and reject this. We don't want any, we have no interest if this is no integer or a float here. Then we're going to define our change. So if we have money left over, like if we have budget minus the price of the shoe, then we're going to go ahead and give some money back. And then we're going to buy the shoe as well. So we're going to have our buy option. As long as our budget is greater than the price of the shoe, we can buy that shoe. And if the budget is equal to the price, then we have enough money. If it's not, then we'll actually have some money left over here. Unless it's the instance of not having enough money, and then it'll just exit the application because we haven't told it to do anything else. And then it'll also thank us for using the shoe app. So that's part one. We have defined the class. Now, could we build this out all in one thing? Yes, we could just write a script out for this. We could code this and make it into one easy script. But what this will do is allow us flexibility. This is where object-oriented programming comes into play, because we don't have to continue to repeat ourselves. And what we're following is what is called the dry approach, the don't repeat yourself approach. And so what we're doing is maintaining everything in a class here, and then we'll call that class and make it very easy on us instead of having one crazy long script that is potentially repetitive and a lot more difficult to go through. So here we're going to just open this up, and I'm going to call out a shebang on bin Python 3. I'm going to save this, and I'm going to call this shoe purchase.py. Save that. Now, we're going to import from our class that we made. So from shoes, import shoes. And let's define a few variables. So let's say low is equal to shoes. And for the low price shoes, we're just going to say we can buy some and ones. And we can buy those for $30. For medium price shoes, maybe we can purchase some Air Force Ones. And for those, maybe they're $120. And then for the high price shoes, maybe we're interested in purchasing some off-whites. And those might run us $400. And from here, what we're going to do is we're going to do a try statement. Remember, we've done a try statement before. And we're going to say try, and we're going to say shoe budget is equal to a float of an input. We're going to ask for an input here. So this is all tying together. We'll say, what is your shoe budget? Do a question mark there. Tie this together. And then we're going to do an exception. So if we have a value error, meaning we don't get a number back, similar to what we were doing previously, if we don't get a number back here, we're going to say, please enter a number. Now, we can come in here and say, for shoes in, and then we can just give this high, medium, low, like this. We can do a shoes.buy. And remember, we came out with this buy method over in our class here. So we're doing a shoes.buy. Going to go ahead and check all this for us. And we're going to say shoe budget. So we're going to take the input of shoe budget. What's the value here? We'll take that. We'll come in here and we'll see what our budget is. If it is greater than or equal to the price of the shoe, we're defining our name of the shoe and our price of the shoe from our parameters that we defined up here, name and price. So we're saying, hey, the name and the price. So is the price of the shoe, is it at least the amount of our budget? And if it is, we can buy that. And we'll check in the highest order and then go in the lowest order. If you flip these and you put in $400, it would just keep telling you that you can only buy the low price shoe. So you need to make sure it's in the highest to the lowest order in this example. And so it'll check, do we have enough money to buy the $400 pair of shoes? No? Okay, and then do we have enough money to buy the $120 pair of shoes? No? Do we have enough money to buy the $30 pair of shoes? So we'll go through that and iterate in this loop to see what we can or can't buy. So let's go ahead and save this. And we'll save shoes.py. And I'm going to go ahead and run this. Hopefully I have no typos. We'll do shoe budget. Shoe purchase, sorry. And run this. And I do have a typo. And so if I come back in here, I forgot to close off my F string. So let me save that. Now let's try this. What is our shoe budget? So let's give it a few different options. If we said our shoe budget was $30 exactly, well, it's going to say that we can cop some and ones, sorry, and we have exactly enough money for these shoes. Thanks for using the shoe app. What if we had $31? Well, we could still cop some and ones, and then we can buy these shoes and have $1 left over. All right. What if we had $450? Well, we can buy the off-whites, and we can buy those and have $50 left over for our budget. So hopefully this makes sense. I know this is a lot of information, and this, again, is just a 101 course. So we're just kind of dabbling in the object-oriented programming. And if you continue on with Python from here and you start getting into more complex material, then you could build upon what you're learning here. So try to think of something that you might want to script out like this or write out like this, and think of the logic behind it. I highly recommend going and doing coding challenges or programming challenges and try to increase the logic and the ideas behind what you're trying to build. And that just takes practice. All of this takes practice. It's one thing to watch and follow along with somebody. It's a whole nother game to go out and do this yourself. So start thinking of some things that you want to build. Really use your Google skills. Look at Stack Overflow and look at some Googling and some Redditing, and just try to piece together the logic that you have in what you want to build. So highly recommend building upon this. This is a great language to learn and very flexible, and I hope that you continue on with this. Okay, before we get hands-on, I have to give you a little bit of death by a PowerPoint, but it's for good reason. So we need to introduce the 5 stages of ethical hacking. These are the 5 stages that you will go through on every assessment. So before we do that, let's first make a big note. From here on, we are moving into the ethical hacking portion of our course. We're going to learn malicious things. Please only use the information learned in this course for ethical purposes. Do not attack your neighbors. Do not attack anybody that you do not have explicit permission to do so. You can and will get into trouble for doing that. So with that out of the way, let's talk briefly about the 5 stages of ethical hacking. So we start up at the top, and we actually start with what is called reconnaissance. This stage is also known as information gathering, and there are 2 different types. There's active and passive. Now, passive is saying like going out to Google and searching for somebody. Say you're given a client and you want to look at their Google, you want to look at LinkedIn, you might be looking for, I don't know, a picture of their badge or an employee's name or maybe an employee's Twitter page. That's all passive. You're not actually going out to the company's website and doing anything active against it. Now, active reconnaissance kind of falls into place with the second phase, which is scanning and enumeration. Now that is active. That is where we go out and we take tools such as Nmap and Nessus and Nikto, and if you've never heard of any of those, that's fine. But we take those and we scan actively against a client. Now what we're looking for are open ports, vulnerabilities, different items, and with what returns on these results when we do this scanning, we also perform what is called enumeration. Enumeration is just looking at items and digging into them to see if we can find anything of value. Say that there is a web server running on port 80. We see port 80 is open and it's running something like Apache 1.2, which would be really, really outdated. We would go out to Google and we would say, Google, do you know if Apache 1.2 has any exploits for it? And we would do research. That's the enumeration portion of it. So once we do our information gathering, we do our scanning and enumeration, then we move into the gaining access portion. This is also known as exploitation. We will run an exploit against the client or against the vulnerable service or whatever it may be to try to gain access into a machine or into a network, into an environment, etc. Once we have that access, the process starts to repeat. We do scanning and enumeration again, and we also want to maintain that access, right? So if we were to get kicked out, okay, or a user shuts down their computer, how do we maintain that access so when they turn their computer back on, we still have access to it? And then lastly, there is the covering tracks. You want to delete any logs that you may leave behind. You want to delete any kind of malware that you upload, which is more important as a pen tester. Any accounts that you create for any reason, you want to delete those as well. You really just want to clean up is a good way of putting it. Covering tracks is the more hacker way of putting it, but as a penetration tester, you really just want to clean up. So we're going to go heavily through steps 1 through 3 in this course. We'll also cover 4 and 5 briefly, but the process and methodology never changes. Regardless if you're doing network, if you're doing web app, or if you're doing a different type of assessment, it's all similar in this 5 stages of hacking. The tools might change, the attack methods might change, but the overall methodology is always the same. So that's how we're also going to structure this course. We're going to go in first and we're going to talk about information gathering and reconnaissance. Then we're going to move into scanning and enumeration, and then we'll start with exploitation and do that repeatedly till we get it inside of our heads and it feels almost second nature, right? Once we have all that done, we'll do some practice boxes, give it a go, see how we do. We'll move into the internal side of things with Active Directory. We'll start working with our web applications and our wireless, and we will touch on the maintaining access and covering tracks, but you're going to see this methodology over and over, and you might also get this question on an interview, to describe the 5 stages. So it's important to know these. It's just something that every ethical hacker can rattle off pretty quickly. So have this written down, think about it, keep your wheels spinning, and let's go ahead and move on to our first section, which is going to be information gathering / reconnaissance. Let's learn some cool tools, some Google foo, and just what kind of information we can actually gather on a potential client. So in this section, we are going to be talking about information gathering. And all the information gathering we're going to do in this section is going to be passive. So I'm calling this passive recon or passive reconnaissance. I wanted to give a brief overview of what we're going to be covering and talk about some high-level topics before we get into the weeds and really dive into our target. So let's talk about the different types of passive recon. So on the physical or social side, physical meaning actually going on site and maybe doing a physical engagement, or the social engineering aspect of maybe doing a phishing assessment or even including it in a physical engagement or a phishing assessment. Just gathering this information from the physical social aspect is incredibly useful. So we have location information. So we might utilize something like satellite images, or often we'll go on site and do drone reconnaissance where we fly a drone around and try to gain information. And what we're really after with these images of this drone recon is we're trying to find out, hey, what does the building layout look like? Are there badge readers? Are there break areas? Does security exist? Do they have somebody posted out up front? Can you just walk right in the door? What does their fencing look like? Are there areas where they're just leaving the doors propped open? Where do people go out and smoke in these break areas? Because those are a good place to just walk up to somebody, light up a cigarette, even if you don't smoke, and just start a conversation, and then tailgate right in with them into the building. Now, the other aspect of this is the job information. So we might be looking for employees online. I might want to know somebody's name, job title, phone number, who their manager is. I try to get a good idea of what people look like. So if I see them on site, I have a good idea who they are. I also look for pictures. So I cannot tell you how many times a badge photo is posted on LinkedIn or somebody posted on Twitter. You can see all the memes out there about people posting their photos at work, and it's bad. It happens all the time. I see it to this day. So we're looking for badge photos. I'm looking for desk photos, computer photos. I had a situation once where somebody took a picture of her watching a game at work. She was watching a basketball game at work, and the basketball game was on her computer, and on her screen there, it showed all the different tools that they utilized at work. She had a work application open in this photo. There was a desk in the background. You can see different things, and it just gives us information, and that's really what we're after. What kind of information can we gather? Now, this course is not a course on physical or social, so I kind of wanted to give a high level of what to expect. We won't really be doing a whole lot of this in this course with this type of information gathering, but these are the things that you should be looking for. So if you are tasked with a physical assessment, do go out there and look for satellite images, try to get a good feel of the building layout, and also try to get a feel for who the employees are, who maybe the IT manager is, in case you're going to say, you know, I work for IT. They might ask you who your manager is. You might need to know those names. And of course, look for pictures. If you can find a good badge photo and what that looks like, you can make a fake badge go on site, and you'll be way more passable with that badge. But sometimes they don't even look. It could be drawn in crayon. So from there, let's go ahead and talk about what we will be doing a lot of, which is the web and host. So when you get a web or a host assessment, the first thing you really should do is what is called target validation. So we're going to be targeting something on bug crowds. We're not really going to focus on this, but what we're going to do in the real world is we would validate the target. Now, there are situations where a client will give you an IP address or a website, and they might fudge it, right? They might accidentally fat finger it, put the wrong number, put the wrong letter in the website. And then guess what? You're off attacking somebody else's website. And there, if you are a podcast listener, there's a good Darknet Diaries episode on this. If you don't listen to Darknet Diaries, go check it out. There's a great episode with a guy named Rob Fuller, aka Mubix, and he talks about getting the wrong IP address on an assessment and attacking the wrong people and actually gaining access to that machine, which is a really, really big screw up on both parts, right? So you should always validate your targets. On top of this, when we're doing our web and our host, on the web side, we're going to look for subdomains, and we'll talk more about that as we get into it. But we can do that with Google, we can do that with Nmap, Sublister. There's so many different tools that we can use, and we'll cover some of the tools and how to do it. Get a little deep into that as well, especially as we get into the website of things. There's fingerprinting. We need to know what's running on a website or what's running on a host. What kind of services are out there? Are they running a web server? What's that web server? Is it IIS? Is it Apache? What version is it? Right? Are they running, what ports are open on their machines? Oh, they have FTP open. What version of FTP is open? So we need to fingerprint machines and kind of understand. But on the passive side, we're not touching any machine, right? So we're not going to be doing much scanning against a host. We just have to utilize what kind of information might already be out there. So if we go out to a website, it's on the border of active, but as long as we're not scanning it, in my book, it's still passive. So we will cover some of the passive/active side in this section, and then when we get into scanning, we'll get way more active with it. Lastly, we're going to hit heavy, especially in the beginning, on data breaches. Data breaches are the most common way when we're doing an external assessment that we get into networks. Absolutely by far. When we talk about data breaches, we're talking about breached incidents from the past that have leaked data. Again, these are like Home Depot, Equifax, LinkedIn, all kinds of breaches that are out there that have had credentials dumped, and then those credentials become available to us eventually, and we try to utilize those to gain access, or at least utilize the usernames to gain access. Nowadays, most of the time, there's not going to be an easy just scan, find something vulnerable, and exploit it on the external side of the house. So we're looking for these data breaches and this information that we can gather. And this is why information gathering and then enumeration and scanning, most important by far. The better scanning and enumeration that you can do and the better information gathering you can do, the better hacker you're going to be and the better you're going to be at your job. So take these first two sections really serious. So we're going to start in with identifying what our target's going to be for this part of the section. And then we're going to go ahead and start talking about data breaches and why they're important and go deeper into that. And then we'll go off some of these tools that you see here on this list and really dive into those. So I will look forward to seeing you in the next video when we identify our target and get some information gathering started. All right, before we begin doing our reconnaissance, we have to establish a client to attack. So for this course, we're going to be utilizing a client out of BugCrowd. If you've never heard of BugCrowd is a public bug bounty program. What that means is there are programs on the website that will allow you to attack them. And if you find a bug against the program, you're able to submit it and potentially get money for it. So you are able to hack these programs publicly as they are part of this program. Now, the program we're going to be attacking is Tesla. So Tesla is part of BugCrowd. Now, please do note, please double check when you're watching this course, as some time may have passed. Tesla might no longer be part of this bug bounty program. So it's very critical to make sure that you are still within scope before you attack. If for some reason Tesla is no longer in scope, just go ahead and pick a new client and do information gathering on them. You don't have to pick Tesla when we're doing this. You can just do it to follow along with me, but you're also welcome to pick any program you want. So if you go to bugcrowd.com and we go to programs, I will show you where Tesla exists. Now you can see here that they have all different types of programs in here. And if I were to scroll down and continuously, I could find more and more and more. There are hundreds of programs involved, all kinds of names, DigitalOcean, Okta, really big names, Pinterest, Atlassian, anything that you can imagine probably has a bug program if it's reputable, okay? Any of the big names most likely have a bug program, especially if they're reputable. So here you could see what's based on reward, what's based on charity, and what's based on points only. That's how the bug bounties are rewarded. Some of them are not all cash. Some of them are just for points and for kudos, and the other ones are for charity. I'm gonna go ahead and just search Tesla. And when I do that, you can see here that Tesla comes up. Now, this is your first lesson into rules of engagement. And we're gonna talk about rules of engagement later, but it's super important to read the program details that you see here And what we really need to do is we need to scroll through and make sure that we stay in scope when we're doing this. So we have a wildcard here. So this means that any subdomain inside of Tesla.com is fair game, Tesla.cn, Tesla Motors, etc. What is more important is that we stay within this out of scope. So we don't want to attack shop.eu.teslamotors.com or energysupport.tesla.com. It says you can report vulnerabilities to Bug Bounty for this one. Any domains from acquisitions, such as Maxwell. So we have to stay within Tesla. And there's a few more sites. We're not going to worry too much about that. When we get into the web app portion of the course, we're going to talk about way more detail on enumerating web applications and go into that. So for now, what we're going to do is we're just going to focus on information gathering. What kind of information can we gather from this client? So again, I'm setting my target to Tesla. If you pick another Tesla or another client, just make sure you stay in scope of that client. So from here, we're going to move on to our first video and get our information gathering started.
Welcome to the email OSINT section. We're going to talk about discovering email addresses. And this is something that I do on a weekly basis. So I'm going to show you the most common tools that I use to actually look up email addresses and try to find people, and what you can do to kind of verify email addresses. So I'll show you some of my favorite tools and concepts. And this is something that I do because not only for OSINT and doing it for investigative type work, but think about sales. If I'm trying to find a lead or I'm trying to find multiple leads within an organization, I have to figure out where the emails are, who the people I'm trying to email are. So maybe I'll Google them and say, who is the CISO or Chief Information Security Officer for this company? And I might find that it's Bob Jones. And we go look up Bob Jones and we say, okay, well, how do I get Bob Jones's contact information? Can I find it via Google? Maybe it's out there in the public, but maybe we have to dig a little deeper. Maybe we have to kind of do some guesstimation and see if we can figure it out. So that's what we're going to do today is look at the email addresses, formats, and try to determine if we can find some emails. So let's go ahead and move over to the Kali Linux machine that I've got. And the first website is one of my favorites. So hunter.io, you just come to hunter.io. You get like 50 or 100 free searches a month. I don't remember what it is. It's a fair amount. You can come here and basically just type in a company name. So like say I want to type in TCM security, TCM-sec, and you can see TCM security here. We get one result on the email address. So we'll click it and see what happens here. And looks like we have like an info@tcm-sec.com. It tells us, hey, there's 5 sources that identify this. So we see tcm-sec.com. There's an about, blog. So this is where they're finding it, okay? A better example, maybe something that has more users, like Tesla. Tesla has 468 users. If we come in here and we look, well, we can see that they have a pattern identified here. So their pattern they're identifying is first initial, last name at tesla.com. And that's really what we want to see. And then we can gather email addresses here if we want. But say like we knew Bob Jones. Again, going back to that example, Bob Jones. So maybe Bob Jones works at Tesla. Maybe his email would be bjones@tesla.com. So it's something to think about. Now, we can sign up and get actual information here. You should be able to sign up with a Gmail account. Sometimes this does not work depending on the country that you are in. So be cognizant, you might have to use a different email address, but I just tried signing up with a Gmail account that I have on here and it worked just fine. So I'm going to go ahead and try to log in. I'm going to sign in with Google with what's already here. And just now I'm logged in. So we can go back now and try searching Tesla again. And you'll see that the results actually come back. So we get information here now. We get, let me make this a little bit bigger. We get information as to, okay, here's the vice president. This is the vice president's email address. Project development manager. Maybe you want to talk to somebody in human resources. So you can click here and go to human resources. And then here are the different human resources emails that are here. So, and then the sources that they found these email addresses. So this isn't a particular person in HR, but it's still human resources email addresses. So this looks like it's probably for Hong Kong. This is for Berlin. This is Gigafactory. So they have different email addresses based on where they are. Now, if you looked up TCM security here, you're really not going to find much on us because we don't have a ton of email addresses out there, but I think that we can find more in other ways. Now, so we only get so many usages here. We'll just keep thinking about this as we move forward. So 100.io, great resource. They have plugins if you want them. I think it's a fantastic place to look. Phonebook.cz is the next resource I want to show you. This one is fantastic. Let's start with tcm-sec.com and see. So we're going to go tcm-sec.com and we're going to search email addresses here. So they do domains and URLs as well, which I think is awesome. But let's just search for email address. See if anything comes back. No results. Okay, that's okay. Let's try Tesla and see what comes back there. Okay, a lot more. So we get quite a few email addresses. We could see Elon Musk all over the place. We got Elon-Musk, Elon. We've got eMusk over here. And we get a ton of emails. Look at this. So what's nice about this is we can sit here and try to identify what the possible email addresses are. So again, first initial last name looks like it's showing up quite a bit. Outside of maybe like the Elon Musks of the world, we're getting a bunch of mostly first initial last names in here. So I think that's pretty spot on with this. The other thing that we can do is we could utilize this list. Say we're trying to do something called credential stuffing, which we'll talk about in the next section, actually, when we talk about breach credentials. But say we're trying to gather a bunch of usernames and test and see if we can log in with those usernames anywhere. Or maybe password spraying, not so much the credential stuffing, but password spraying, where we take all these usernames and we just throw it at a login form and say, hey, summer 2020 exclamation point. See if that logs into any of these accounts, and you would be surprised. It happens quite a bit. So this is valuable information, even if we don't know exactly. Maybe we're not just hunting for one email. Maybe we're hunting for an entire domain. This is a great way to get free entire domains with a quick copy and paste capability. Like we have the Tesla here, we can export the CSV from hunter.io, but you only get so many results that you can export into a CSV. Here you get a bunch. There's no guarantee these are all valid, but it's still information. Information is what we want. This is all we're trying to gather, is as much information as possible. So these are all potential email addresses for tesla.com. I think it's a great resource. Now, we could also use something like Voila No Bear. Now, this one, you can get 50 more leads for free. I'm not going to show you. It's the same kind of deal as 100.io. They're showing you how to utilize it here. Basically, you can just search for people and see to try to find their email addresses. There is one I want to show you that I do use and I have quite a bit of success with, and that is called Clearbit. And Clearbit has to be used in Chrome. So I'm going to bring up this here. Clearbit has to be used in Chrome. So you can download the Chrome extension for Clearbit. And all you would have to do is go to Google. Let me log in really quick. And then I'm going to just select the free account. We get so many searches, 100 emails a month. So basically, you're going to search for Clearbit Connect, and you would just say, hey, Clearbit Connect. I'll put a link down below, by the way. But Clearbit Connect is awesome. You'll see why here in a second once I authorize this. Okay, we're going to come down here, acknowledge, probably give out our firstborn. And then now we're going to say, hey, I want to find emails. And here's all different kinds of things that we can sit here and search for. You can see TCM securities in here. These are some searches that I've done. These aren't any clients of mine. These are just searches that I've done in the past, maybe looking for information or looking for possible leads or anything. So if I come in here and I say, hey, I want to look for TCM security, you could type that in. I'm going to just click on TCM security. And look what it discovered that the others didn't. It discovered me. Okay, and if I click on me, look, it says heat that tcm-sec.com. Where did that come from? And then look, it has my LinkedIn right here as well. That's amazing. That's awesome. And it says here, you can email Heath. Just click this button. And then it's also got Rizwan. Rizwan's on my sales team. Look, it's got Rizwan at tcm-sec.com. What does that tell you? That tells you that we're using a first name basis for our email addresses. It's awesome. Now let's come in here and maybe we want to look at Tesla. Maybe let's try Tesla one more time. Maybe we're looking for the CISO of Tesla if Tesla has a CISO. You could come in here and look, like Elon Musk is right here, obviously CEO, but you could come in here and maybe go by role, and they have different roles in here. So CEO, let's see if we can find any sort of CISO. I don't see one, but I do see information technology. So maybe we can find somebody in the information technology department or IT department. And then here we go. We've got quite a few IT people. Here's a CIO. This could be somebody of interest that we might want to reach out to. And we could just scroll through this list and find people. So say we want to reach out to the CIO, just click on this. We get first initial last name, just like we thought we would. We get this person's LinkedIn page. We get their location, website. This is awesome. Awesome, awesome. So I typically will start with a Google search. If I'm trying to hunt something down, I will start with a Google search. I will say, who is in this role at this company? If I'm looking for a specific person at a company, then I will go to phonebook.cz or hunter.io, try to identify the formatting of the email, and then try to find that person or guesstimate that. Once we get to that point, I try not to burn through these Clearbits unless I need to, but Clearbit is very good at identifying this. Once we get to that point, we can take this email, say like this email, or we'll even try a different email. I'll show you a couple. But we could take this and we can go try to verify this. So there is a website called Email Hippo. You can go to tools.verifyemailaddress.io. And all you have to do is type in an email address here. Sometimes you can get false positives if they're good or bad. Here, I typed in this email address a couple times and just got a bad result. This is an email address that does not exist. Now, let's try an email address that we saw, info@tcm-sec.com. See if it works. Result is okay. So it says, yeah, this email address works. So we're verifying that this is up. So say that you get somebody and you see that they have a potential email address, you can come here and try to verify it first and see if it works before you go fire off an email. You don't even have to fire off an email. You don't have to do anything or interact. So this is the benefit. Like if you're from a sales perspective and you're doing OSINT here, this is the benefit of not having to email, waste your time, get it rejected. You can come in here and just validate. If you're doing an investigation, you don't want to interact with the person or company that you're investigating. You want to come in here and just verify without any interaction. This is the way to do it. Same thing with this website here, emailchecker.net/validate, email-checker.net/validate. Say, hey, checking the email. I put the same email address here. You could see it says bad. We could try again with info@tcm-sec.com and see if that works. And it says okay. So again, this is doing a great job. There are possibilities of false positives. There are so many searches that you can do per month on these, I do believe. They have APIs, which is nice if you want to automate this or script this out. But I think this is fantastic. This is great stuff. Now, there are plenty of other ways to verify email addresses. In the next section, we'll talk about that even more as we talk about breach data. Because if somebody shows up in a data breach, guess what? That email address has been used in the past. If you look at something like a have I been pwned, which we'll talk about in the next section, and they show up, guess what? That person's email address has existed. So we're trying to verify if an email address exists, who that address might belong to, etc. Now, this has been from a business perspective. Some of this hunting down of emails may be more difficult to do if you're trying to find a specific individual. That's where breach data comes into play in a lot of this research. And what I'm going to show you in the next section, we'll try to hunt down individuals with maybe having loose pieces of information like a name or a username or something along those lines. Breach data can come in handy very, very well. So this is kind of scratching the surface. Now, there's one last thing I want to show you, one last little tip and trick. Do not underestimate forgot passwords. Do not underestimate them. Let's go to Google, for example. Right now, I am logging in under an account that is please don't hack me, sir, please. So it's please don't hack me, sir, PLZ, I do believe. I'm going to go ahead and try hitting next on that. Okay, so first of all, it said, hey, welcome. And what does this mean? This means that we have a valid account here. That's great. This is validating that this Gmail account exists. Here's something else. We can use this to tie to potentially another account or help validate. Say we know that this email belongs to somebody that's harassing somebody else. We don't know who this person is. They're using this spoofed email, but maybe we have a hunch or maybe we don't. Maybe we just want to try to get more data. You can come to forgot password and it's going to say, what's the last password you remember using? I don't know. Let's try another way. You come down here and it says, hey, let me make this bigger. Google will send a verification code to H. And it says, look, it shows you the rest of the digits here. And then at TC here. That would give you a pretty good indication if you're tracking who your subject is, that this email could tie to somebody else. Look, this is Heath at tcm-sec.com. Okay, so this email belongs to me. This is tying back to me. Now you have another point here. So if you knew about this email address and now you have the link, the connection to guarantee that this person, this is evidence right here. Say you were doing something, which we'll learn about again in the next section, where you're looking through breach data. You find a username that matches this email address and also matches this email address, but people can reuse usernames. There could be multiple people who use the same username. So you need to verify or some link. This would be a proof of a link between those, a pretty strong proof if you ask me. If you can say, hey, I identified 2 email addresses with the same username. I did an account recovery, came in here and saw that this had this same first character and first domain name. I think that's a pretty strong correlation. So things to think about, wheels to be spinning. Try to identify email addresses in any way possible. We'll cover this more in depth in the next section. And I'm really excited because password hunting is one of my favorite things. So let's go ahead and move on to the next section when we talk about password OSINT. Okay, so I would like you to go out to github.com. And then once you're there, go ahead and just do a /h Maverick Adams, HMAVERICK Adams, and hit enter. And you can see me in my snazzy photo here. But what we're after is, I want to show you a tool that I wrote called Breach Parse, and we're going to walk through what it does. Now go ahead and click on Breach Parse. And you're going to see a bash script here and a little bit of a description. So you do not need to download this. Let me preface with what we're doing here. This magnet link, you're going to need a torrent, some sort of uTorrent or BitTorrent, and you'll need to download this. And it's also something along the lines of 44 gigabytes extracted. It's a huge file. So you don't have to do this. You can just watch and follow along. You are more than welcome to install this on your machine. I'm going to show you what it looks like. So I'm going to go out to my applications and my files here. And then I have put this into my opt folder. So if you come into opt here, and I've got breach parse. If you come into this breach compilation folder, which is what we'll download, you're going to see that we have data here. Okay, so this data has a bunch of different data. It's got emails starting with 0, 1, 2, 3, 4, all these different ones. What's living inside of this is, if we can display it, is emails and passwords. Now you see these ones have weird symbols inside the emails, but there's a bunch of emails and passwords in here, like somebody at yahoo.com and their password is 123456. Well, these passwords are coming from credential dumps. So we talked about it earlier about thinking about the, Equifax or the LinkedIn breach or Home Depot, all these big breaches that happen, credentials get dumped out. And guess what? They show up on the dark web and eventually they show up in these lists. So we utilize these lists, and we've got, if you click into this, just hundreds of files here, and again, 44 gigabytes. So what I did was I built a little tool that can search through this data and pull down names. So you can take a quick look at the tool and what it does. But basically what it does is you just put in the syntax, you search for something like at tesla.com, and then you specify, tesla.text.
and it's going to search through all of these files for @tesla.com. If you're more interested in the code behind it, you're more than welcome to read the code in here and see if some of the items that we've covered already with the bash scripting and the Python scripting kind of ring a bell. So what we're going to do is I'm going to come ahead and go into the terminal and make it a little bigger. And then I'm just going to change into that op folder, breach parse. I'm going to run breach parse. So breach parse here. And what we're going to do is I'm just going to say @tesla.com and then tesla.text, and that's going to run. So again, you do not have to install this. This is only for visual purposes. I'm going to show you in the next video another way to do this. So this is going to run through. It's going to take a minute here, and it's going to grab everybody's username and password that says tesla.com and the username, and then it's going to have all the passwords. And we're going to be able to decipher things from this. So I'm going to let this run, and as soon as it's done, I'll come back and we'll talk about the results. Okay, the results are back. So this breaks it down into 3 files. There is it's cat Tesla. There is a master, passwords, and user. So the master has the username and password, and then the users file has the users, passwords has the passwords. So I'm going to actually gedit the Tesla master.txt, and let's take a look at this. So from here, we don't have a big list, surprisingly, for a company the size of Tesla. So what happens is people utilize their work credentials or their work emails, and they log into websites and probably shouldn't be using their work emails for, and we just use it to our advantage. So what we're after not only these usernames, but we're after these passwords as well. So we see these usernames and we see these passwords, and I like to look for repeat offenders. I like to look for the syntax as well. Remember, we had first initial last name, but we see first name dot last name here. We see possibly, just a single name. There are different types of things in here. So Nick at tesla.com as well. So, it's changed up. I think nowadays it is first initial last name, but maybe in the past they used first name dot last name and then moved to an easier format, or vice versa. They started first initial last name, they got too big, then they had to do first name dot last name. But again, what we're after here is potential repeat offenders. So look at this shark at tesla.com. It got popped twice. And the password is very, very, very similar. So if I were to attack tesla.com through a login interface, I might spray this username with this password and this password. That's what we call credential stuffing, because we already know the passwords. And then I might make some modification of capitalized letters and non-capitalized letters with DADE, because 907 and 814 appear to be consistent. So I would alternate capitals and non-capitals here in lowercase and just see maybe if something sticks. So this is something that's interesting. This user down here, 12345, 12345 star, probably not going to get in with that on a company like Tesla, but you never know. But this is what we would do. We would take the usernames and we would throw these passwords at it, and that's called credential stuffing. And then we would take these usernames and all the known usernames, and we would spray passwords at them, like fall 2019, like we talked about in the last video. That's password spraying. So this is an important and very, very critical part of information gathering, is gathering these usernames and these credentials. Right off the bat, you want to identify those with your targets. So this is kind of what it looks like. This is what I do during every assessment, and hopefully that makes sense and that works into it. In the next video, we're going to go ahead and just show another method and start thinking again about these credentials and how they can be utilized. And then we'll do some other information gathering as we move on and learn some techniques and how we can get information on a client. So I'll see you over in the next video.
Okay, let's talk about hunting breach credentials, and let's get hands-on. Now, before we get started, I know I stressed this in the beginning of the course. I'm going to stress this again. What I'm going to show you here could change. Now, I released a course about a year ago which was on ethical hacking. We talked about breach credentials, and I utilized a website called WeLeakInfo. WeLeakInfo was then eventually shut down, and I got all kinds of emails saying, hey, this is shut down. I don't know what to do. There's more out there, okay? There's always more out there. What I'm showing you is the methodology. I could show you on a specific website, which I'm going to do. That website could go down tomorrow. We never know. But what you need to retain is the thought process and the methodology behind what's about to happen. From there, you could take that and utilize it elsewhere. So if a website does go down, you still have the same thoughts, why you're doing it, and why you're thinking about it. So let's go ahead and move over to a website now. So I want to take you to a website called dhash. Now this is dhash.com. I do not expect you to be able to follow along at this point because this costs money. Okay, it's $5 for a week. It's $150 for a year. This is only, it used to take credit card. They only now take Bitcoin, I do believe, or some sort of cryptocurrency. Absolutely worth it, in my opinion. Even get a week. Get a week, see if you like it. It's amazing. There's going to be tools I show you later on in the course that will go through and we can do it locally, like the one I just ran in the last video. I ran breach parse, right? This is something that I put together and set up, and it's free, but the database isn't maintained. It's a slow search. I don't get the results back as instantly, and I can't tie it to as many data points as a website like this can. I think this website's great. Now let's talk about what dhash can do now that I'm logged in. We have the ability to search by, let me make this a little bit bigger. We have the ability to search by email, username, IP address, name, address, phone number, VIN. Okay, think about this. Say we know a email address. Okay, we know an email address. Say it's bob at tesla.com. We're not going to search this yet. We take Bob, and we know Bob, it has an account, and we're looking for him. We search him. Bob shows up. And we see Bob shows up, and we see maybe his name, like Bob Jones or something like that, shows up. Maybe something that he's been leaked in has his address. Or maybe there was an IP address tied to the client you're looking for or the person you're looking for. This can all be identified. What if Bob has a username? It's like Bob Rocks 123. Okay, well, we can search that username in here and see if that username has repeated itself at all, which is great. We could search by password. So say Bob's password was BobRocks123. We could search that password, and if it's unique enough, then maybe we can actually do some advanced searching. Like if we go back to the example from last time, like this last video, we saw this 907DADE814. We could put that into a search engine and see if that comes back to something else. Maybe that comes back to a user that is not at a tesla.com, but maybe it's like Bob at gmail.com. And then guess what? Now we have Bob's personal account, or now we have Bob tied to another email account, especially if we search by name or something that we can tie them together. We need to start being able to relate other accounts to each other. We can do that with hashing. We can do that with passwords. There's a lot of things that we can do, and we want to start tying this together. As a real world example, when I am looking at an organization and I'm doing research on hashing, or I'm doing research on breach credentials, I'm trying to think, okay, first, if my client is tesla.com, I might come in here and search at tesla.com, and I might come see how many results are in here. Let's see what happens. Okay, here's George at tesla.com. George has been in a shared data, so there's no actual any details here besides a potential username, a name, email. Okay, same thing with safety. We'd have to scroll down and see if we can find something that, okay, here's Adobe. Now Adobe will have there's actually a Bob at Tesla. Bob at Tesla has a hash password here. Okay, so now we could say, well, first of all, we can go see if we can figure out what this hash is, which we'll talk about in a second. We can also go and say, okay, Bob, does Bob exist anywhere else? Does this hash exist anywhere else on this website? Can we tie it to another account that maybe, even if we don't crack the password, then we can say, okay, this ties to Bob at gmail.com. So like I would note this down and I would take this and copy it. So from a real world example, I would take all the data that I see on this website. I would collect all of the passwords, all of the usernames, everything. So like Tesla 9, all of this. I want to know what the passwords are. I want to know who the people are. I want to know all the data. Because if I could start finding patterns, if I could start putting things together, maybe I can even relate these back to their personal email accounts like we're talking about. And then I can see password patterns there or other passwords and just start tying this down. Because my goal is to break into an organization. If I'm doing a pen test, my goal is to break into an organization. So I'm going to take that data, and if I can find other passwords related to a personal account, I'm not going to go attempt to break into a personal account, but I will take that data and I will put it together and maybe try to break into their work email account with those passwords of that information. This can tie to an investigation as well. If you're hunting down an individual, you're trying to tie them to other accounts, this is incredibly useful. If you can find their data in a breach database and have a password, and that password's unique, you can search it, maybe find them somewhere else. You find an IP address, you find a name. There are often IP addresses in here which we can tie to a location possibly. And see, here's that 9078 or DADE 814. We could take this and maybe search it and see if it comes back anything. Who knows? Shark at Tesla. Okay. Shark at mail.ru. Look, this is a new email address. We didn't know about this one before. And look, it does us a favor. We searched DADE, but here's the capitalized. We didn't search for capitalized. We're not searching specific. Okay, and now we're getting more information. Look, here's one for Dropbox. Okay, so it tells you where this is coming from and how you can tie it in. If we can get any sort of name out of this, any sort of anything, that would be amazing. We can get a person's name or IP address and we can start tying them down. But when you're doing different searches like this, you need to start almost, like in the investigations where they have like the red yarn and it's going from one pinpoint to another. You kind of have to zigzag that back and forth and really try to tie this down. And you'll see that when we get into reporting, how you might take one individual and really just see like a password tied to an account, tied to this. And this was the exact methodology that we took to get to that point. Because when you write a report, you want to make sure that the investigative person, or say you're handing off to the police or whatever, you want to make sure that the person that is doing what you did, or they can replicate what you did with ease, and there's no question about it. So this is some of the searching that we can do. Now, if we come to dehashed, again, we can come here and we can search by email, username, name, anything. So you can put your name in here. I mean, if you want to search on here, I think it's great. You can come through here and just search for your name. Let's go back. Let's search Tesla again. I saw a hash in there. The Adobe hashes are kind of interesting. They're not the easiest to pick up, but let's see. Let's find this Adobe hash. So let's say we get a hash like this. We could try to identify what this hash is. We can try to crack this hash. We can see if it's been cracked somewhere else. This hash, as of right now, we have no idea. But we know Bob at Tesla.com. We can maybe paste this in here first of all and see if it ties back to anything. And there's 22 results back. I would probably be looking for somebody that has this password with the name of Bob. It's probably not going to be like a Brett or a Michael. We might want to see if we can find another account somewhere else, but these are all tying down to a hash from Adobe. So depending on how they were hashing this data, we might not find anything else of interest. But you can see all the things here, all the different opportunities that are here for us to just do research and tie down information. Now we can go to a website called hashes.org. And if we come here, we have the capability to actually try to search for this hash. So we could search hashes and see if we can find it. So you can come in here and just paste it. And again, it doesn't do a great job, in my opinion, with the Adobe hashes. Sometimes they crack, but a lot of times it says it can't find them. Oops, there we go. Let's try hitting a search here. Okay, so it says not a valid hash. Now, if you put this into Google as a search, you can see it didn't come back with anything either. So we want to make sure that when we're searching this, we try all options. There is an Adobe database that if you do put in a hash and it does show up, there's a GitHub Adobe database that will actually show up here. So with that being said, this is kind of what I want you to start thinking about when we're hunting down breach credentials. How can I take a person or company that I'm looking into? So if you have a company, you can just go at companyname.com or .net or whatever it is, search in here, see how they show up. If you have a person, maybe a personal email account, if you can find that person, if you know their email account, you come in here and say bob@gmail.com. Maybe you don't know what their email address is. Then maybe you come here to the main page, you go, okay, I'm going to look for a name. I'm going to look for Bob Jones and search for that. And then you start taking this and trying to find the patterns. If you know Bob lives somewhere, maybe you could find an address for Bob, or maybe you know Bob lives in like Arizona. You could search Bob Jones and see if Bob shows up, and then kind of take it from there. And there is some search operators that you can utilize. You can see Bob Jones is taking forever. You can put this in quotations and search it again, and kind of narrow down your results here. So if we click on this, you could see like, here's a name of, we got a lot of results, but here's the name of Bob Jones. This is a very common name. So, but you could see like, if we're trying to look this down, we can start searching and adding operators in here and trying to see if we can figure out to tie a username or something to them. So again, get your wheel spinning. Don't rely on just dehashed, but just rely on thinking about this. This is the thing you should be thinking about. Again, dehash could go down tomorrow. But if you're thinking about it in the way that the credentials and the information can be interwoven, remember that red yarn again, that's really what I want you to take away from this. So we're going to do another video on this. I'm going to show you some more, I guess, tools that are out there and some other things that you can do, offer alternatives to this, and then we'll wrap up this section. So I'll catch you over in the next video.
Okay, we have reached the end of part 1. I am again going to link in the description below the link to part 2. So go ahead and click on that if you finish this, and we're going to meet you over in part 2 of the video.